This is R.D. Sharma solution, class 12, chapter 12. Higher order derivatives. Exercise is 12.1. Find the second order derivative of the following function, x cube plus 10x. Now, higher order derivative or second order derivative, it is all about deriving multiple times. How many times you have been asked? So, dy by dx is the first derivative or derivation. In second derivative, we derive the derivation. Okay. So you have to differentiate this function twice. So d2 by dx2 is nothing but differentiation of x cube plus 10x twice. So let us regard this as y equals x cube plus 10x as a function. So we have an algebraic function also and the trigonometric function also. So you need to know the differentiation of all these. Then only you will be able to understand the higher order derivative. So dy by dx is first order derivative, x cube is 3x square, 10x differentiation is sec square x. Then we have the d2y by dxt. So we have d by dx of dy by dx, that is the second order derivative. So this will be d2y by dx2 on the left hand side. On the right hand side you have to differentiate again. So 3x square differentiation is 2x. Sec square x, the differentiation is 2 sec x, and then the differentiation of sec x is sec x tan x. So what do you get? 6x plus 2 into sec and sec will be sec square x. Then we have tan x. Okay. So now you see, if you have to write it in your exam, then this is the way you have to write. Like you have to say we have differentiating with respect to x, again differentiating with respect to x. Find the second order derivatives of the following function. Now we know already how to do this, okay, differentiating twice. So this solution, those who want to do by themselves, they can do it. I'll take a different approach. So y will be equal to sine log x. So first we have to find out dy by dx, that is y prime, y dash. So you can just write it as y prime also, y dash also. This is equivalent to saying that it is dy by dx. So d2y by dx2, this y prime will become y double prime. So sine theta, what is the differentiation of sine theta? It will be cos theta. So it will be cos log x. Now you have to differentiate the log x also inside. Okay. So sine is cos log x is 1 by x. So y prime is cos log x by x. So as we know, by normal differentiation, there are two ways to do it. You can use the product rule also. You can use the other way, that is the quotient rule also. So d2y by dx2, which is equal to the y prime, double prime actually. So on the left you see already have provided the solution for those who just want to go ahead. So I am doing it using the better way is to do it using quotient rule. So we have the square of the denominator, so x square, and as I said, cos log x into 1 by x can be done by the product rule. So we'll be following the quotient rule here. Okay. So this is there are different approaches for the same question. Whichever you are comfortable with, you can follow that. So the denominator becomes square, now denominator, and differentiation of cos log x. So cos log x will be minus sine log x, cos is minus sine log x. So it will be minus sine log x, and then differentiation of log x will be 1 by x. So I'll just put the negative sign just now. But let us see, you have in quotient rule, you have a negative in between. Now cos log x will be outside. Now you have to differentiate this one, the denominator. So differentiation of denominator, which is x, is just 1. X to the power 1 you can assume like that, and nx to the power n minus 1 you can apply. So as I said, this is minus sine log minus sine log x. So I'm putting a minus sign here, and here also we have a negative cos log x. So you can cancel these two, xx, negative you can take common, minus common. So inside this will be sine log x plus cos log x. So negative is outside. Now in the denominator you can just square it. So this is your final answer. Both way, by product rule or quotient rule, you are going to get the same answer. Next one is log sine x. Same thing we have to do. Second order derivative, that is differentiate the function twice. So you have y equals log sine x. Let us differentiate it with respect to x, or you can also write it as y prime. Log theta or log anything is 1 by that thing. So 1 by sine x. Differentiation of sine x will be cos x. So cos x by sine x is simply cot x, and we know the differentiation of cot x. So y double dash will be quite easy here. Cot x is minus cos x square x. So the second order derivative of log sine x is nothing but minus cos x square x. You have to write like this. Now find the second order derivatives of the following function, e to the power x sine 5x. So you have to differentiate it twice. Okay, those who want to do by themselves, but we will do it. We all will do it. E to the power x sine 5x. So e raise x, sine 5x is cos 5x, and differentiation of 5x will be 5. This will be 5 e raise x cos 5x. Then we have a plus. So now you can take this sine 5x outside, and differentiation of ex will be ex, e raise x. Okay. Now this is only the first differentiation that we have achieved. But since the question is asking about second order derivative, y prime y double prime we have to find out. d2y by dx2 we have to find out. So now there are two different terms with an addition sign in between. So what we'll do, e to the power x or e raise x cos 5x we will take separately. Cos 5x is minus sin 5x, differentiation of 5x will be 5. E raise x we have just kept it like this because we are applying the product rule here, product rule. Then we have the cos 5x will not touch, will only differentiate e raise x as I just suggested. We are following the product rule. E to the power x will be e to the power x only. So this is the 5 also. 5 is to be multiplied. So minus 5 e raise x sin 5x, and this 5 5s are 25. So there is a 5 inside also. Then we have plus 5 e raise x cos 5x. Alright. Now this is for this one only. This is the first part. Now we'll do the second part. So e raise x sin 5x. So e raise x sin 5x is cos 5x. 5 will come outside because 5x differentiation is 5 only. Then we'll not do the sin 5x. We'll only do the e raise x. So sin 5x, e raise x will be e raise x only. So now just add them because it is addition only. Now e raise x, sin 5x, e raise x, sin 5x, they are two terms. So 1 is there and minus 25 is there. So 1 minus 25 is minus 24. So minus 24 e raise x, sin 5x. Then we have this 5 and 5 will become, this will be 10 and e raise x cos 5x. So it will be plus 10 e raise x cos 5. Okay, so this is your final answer, but you can also simplify it more. First of all, negative sign is always kept wherever it is possible in between. So 10 e raise x cos 5x we will take first, and then negative 24 e raise x sin 5x. But by doing this, we also see that e raise x is common between these two terms, and also if we can take 2 also common from these two terms. So this we will do like this. 2 I am taking outside. E raise x I am taking outside as common, and what will be inside? It will be 5 cos 5x, and here you have minus 12 sin 5x. Okay, so are they matching? Yes, they are matching. So this is how you can simplify also. So write the answer as simplest as possible. Now same thing here, almost same as the previous question, but we'll do it. Those who just want to go ahead because they have understood how to do this, they can move on to the next question, but I'm going to do this. E raise 6x cos 3x, y prime is e raise 6x, we'll keep it like that. Cos 3x will be minus sin 3x, minus sin 3x, and then differentiation of 3x will be 3. Then we have plus cos 3x will remain like this. E raise 6x, so e raise 6x, differentiation of 6x will be 6. Okay, so let us multiply whatever is there. We have a negative here and we have 3 here, so put 3 here. E raise 6x will be there and sin 3x. So we have first term like this. Remember, it is just the first derivation. Second one is 6 e raise 6x cos 3x. So you can match this. If you, as I said, who want to do by themselves, they can just have a look. They can refer to the solution. Now, we have to put this negative in between. We always say that negative should be in between. So, I'm just swapping the terms. It will be 6 e raise 6x cos 3x minus 3 e raise 6x sin 3x. Then we will do the differentiation again. That is the second order derivative we have to compute. So we'll just forget about the constant right now. We'll concentrate on e raise 6 cos 3x. But what do you see here? E raise 6x cos 3x has already been done. The question is only this one. So we can just directly take this content and just put it here in the place of differentiation of e raise 6x cos 3x. So I have a 6. Now I am writing the y prime, which is the differentiation of the actual function as it is. So it will be 6 e raise 6x cos 3x minus 3. Then we have e raise 6x sin 3x. So we'll take the common later because we are going to solve it, and I'm multiplying it. 6 6 is 36, 36 e raise 6x cos 3x, and then we have 6 into 3, that is 6 3 is 18, 18 e raise 6x and sin 3x. We'll take e raise 6x common later, but there are certain terms which are coming from the second term also because we are doing the second differentiation of e raise 6x sin 3x. So we'll multiply it by 3 later. Let us do e raise 6x sin 3x separately. So e raise 6x sin 3x, so e to the power 6x, sin 3x will be cos 3x, differentiation of 3x will be 3, plus then we have sin 3x, differentiation of e raise 6x will be e raise 6x, differentiation of 6x will be 6. So what do you get? 3 e raise 6x cos 3x, this is the first one, plus we have 6 sin 3x, then we have e raise 6x. Now you have a 3 also here. So let us first multiply it by 3, and there will be a negative sign also. We'll just change the sign and add it to the first term. So 3 is a 9, 9 e raise 6x cos 3x, and then we have plus 6 is a 18 e raise 6x sin 3x. Along with this, we have this term. This is negative. So I am taking this, what we have done, and I am putting it in this equation. So it will be 9 e raise 6x cos 3x minus 18 e raised 6x sine 3x. As I suggested, these because it is negative, so we have just changed the sign. Now combine the equivalent terms. So e raised 6x cos 3x here also. So 36 minus 9 is nothing but 27. So write it as 27 e raised 6x cos 3x. And what about the other two terms? Because we have the similar terms, which is e raised 6x sine 3x. Minus 18 is minus 36. So you have negative 36 e raised 6x sine 3x. This can be a final answer, but you can resolve it more to write it in a simplified way. So we have the 9 multiple here. So 9 you can take out. 9 3s are 27 it is. E raised 6x also you can take common. So you have 9 3s are 27 here. Cos 3x minus, what is it? So we have 4 sine 3x. So this whole term is this one, which is also the answer. Find the second order derivatives of the following function: x cube log x. Okay, see x cube log x, this is quite simple. If you want to just go ahead. X cube log x. So I'll not write all that we have differentiated with respect to x. I hope that you'll be able to write it. So let us differentiate it, find out the y prime or dy by dx. So x cube, and then log x is 1 by x, then log x, differentiation of x cube is 3x square. We have applied the product rule. This gets cancelled. You have x square plus you have 3x square here, then log x. Again we have to do the differentiation. So this was y prime. We have to find out y prime. We have to apply the y prime differentiation of this again. X square is 2x, then 3 differentiation of x square log x. Let us do it separately. X square log x is 1 by x plus log x, differentiation of x square is 2x. So just cancel this, you get x plus 2x log x. Now just put it here with a multiple of 3. So 3 into x plus 2x log x. You get 2x plus 3x plus 6x log x. 2x plus 3x is 5x plus 6x log x. This will be your final answer. If you want to see the answer also and how you are going to write it, this is how you are going to write it. But do remember, you have to write it very neat and clean and with all the wordings and sentences like this. You have to show each and every step to the examiner or the teacher. Now we have an inverse trigonometric function here, which is tan inverse x. And I hope you have all the idea about the differentiation of the inverse trigonometric function. So y equals tan inverse x. Y prime, that is dy by dx, is tan inverse x is 1 by 1 plus x square. Now y double dash, that is the double differentiation is, now you can do two things. Either you can use the quotient rule or you can make it simpler, because anything which goes up, the power sign will be negative. So 1 plus x square, when it goes to the numerator, it will have a negative sign. And you know x to the power n differentiation is n x to the power n minus 1. So minus 1 plus x square to the power minus 1 minus 1, minus 2 you can write. So 1 plus x square differentiation has also to be done. 1 plus x square is 2x. You just write 2x. So you have a negative 2x, and 1 plus x square to the power minus 2, you can bring it down. So you have 1 plus x square here, and this is going to be your final answer, which is going to be your double differentiation. Alright. Now we have x cos x. Let us do it quickly, because now I hope you have got a fair idea. X cos x, y prime or differentiation dy by dx is x, cos x will be minus sin x. I am applying the product rule. Then cos x will be like that only, differentiation of x will be 1. So you have, and cos x I am bringing first, then minus x sin x here. So now we have to do the differentiation again. So this will be double differentiation, which is the second order derivative. Cos x will be minus sin x, and then x sin x I will do it separately. X sin x is x, sin x will be cos x. Then we have sin x, differentiation of x will be 1. So this, when I will write it here, I have to change the signs. So minus x cos x minus sin x. Now you see minus 2 sin x it will be there, because there are minus sin x and minus sin x will be minus 2 sin x. You already have a minus x cos x. Now you can take a negative outside, you will get 2 sin x plus x cos x. So this is y double dash, or you can say d2y by dx2, or the second order derivative, or the higher order derivative of x cos x. Log of log x, y equals log of log x. So differentiation of log anything will be 1 by that thing. So dy by dx of log x, y prime is so 1 by that thing. So 1 by log x. Now you have to differentiate log x again. Differentiation of log x is 1 by x. So you have 1 by x log x. Now there are two ways. Either you apply the quotient rule, or as I just said once, one question before, I guess, just take it in the numerator with a negative as a power. So x log x to the power minus 1, and you know that this x raised n differentiation is nx to the power n minus 1. Minus 1 coming, 1 will here, x log x to the power minus 1, that is minus 2. So now you have to do x log x also. So x log x differentiation is x log x is 1 by x plus log x. You can just write it as log x, differentiation of x is will be 1. So you have 1 plus log x. So just write 1 plus log x here. You have a negative x plus log x to the power minus 2 can be taken into the denominator. So you have 1 plus log x negative, and you have x log x in the denominator square. So this is the answer. As I said, there are multiple ways to do it. It's up to you how you do it. You can apply this way also. You can apply the quotient rule also. But the main essence is you have to differentiate the content of the function twice. That will be regarded as the second order derivative. If y is equal to e raised minus x cos x, we have to show that d2y by dx2, that is the double derivative, is equal to 2e raised minus x sin x. That means you have to derive or differentiate this twice. Okay, so let's start. Y is equal to e raised minus x cos x. Y prime or dy by dx we'll find out, and this is going to be, let's take e minus x outside, then cos x will be minus sin x. So I'm applying the product rule, and those who want to do by themselves, take a reference, they can have a reference. Let's proceed with our solution now. Minus sin x, then cos x will remain like that. I'm indicating you the product rule. E raised minus x is e raised minus x, but you have to differentiate negative x also. It will be negative 1 then. So we'll take a negative outside because there are two negatives inside. So we take a negative outside, and whatever is remaining we'll keep it inside. So this is e raised minus x sin x. Here we have plus e raised minus x cos x. Okay, now we have to do d2y by dx2. Y double prime or d2y by dx2. But when we are doing this, we have to see that when we differentiate e raised minus x cos x inside, which you see the second term here, that already we have done. So this differentiation already been done, and the result is this one. So we are not going to differentiate it again. We are going to put the same result in the final d2y by dx2 directly. So we'll differentiate e raised minus x sin x separately. So we have this minus, I'm just doing e raised minus x sin x now. So e minus x sin x will be e minus x like that, sin x. This is differentiation we are doing, e raised minus x. So we are doing the d2y by dx2 of this. Sin x will be cos x, then sin x will come here. E raised minus x will be e raised minus x. Differentiation of negative x will be negative 1. So I'm just replacing it by negative. So in this place, I am writing this e raised minus x cos x minus sin x e raised minus x. Okay, this whole content we have to put here. Okay, so this total one, in place of e raised minus x cos x, you have to write minus in the brackets e raised minus x sin x plus e raised minus x cos x. So since we have a negative, let's write the previous one only, e raised minus x sin x minus e raised minus x cos x. So what all the cancellation can be done? This is being cancelled, e raised minus x cos x, and this will be minus 2 negative 2 sin x e raised minus x, and minus is already outside, minus will be plus. So 2 sin x e raised minus x, or you can take e raised minus x in the front. This is your final answer. This is how you have to write also. Y is equal to x plus tan x. So we have to show that cos square x d2y by dx2 minus 2y plus 2x equals 0. Now if you see in the solution, that is what they have wanted from us. They're wanting from us is cos square x, and there is 2y plus 2x also, that is negative 2y plus 2x. So we are not getting any point right now, so it's better that we just go ahead. That means we just go ahead and try to solve the way it is. Y is equal to x plus tan x. So this is dy by dx. This is equal to x is 1, and we have tan x as sec square x. So we have d2y by dx2. See, we have to differentiate it again. Let's differentiate it again. So d2y by dx2 will be equal to 1 will be 0. The differentiation of 1 will be 0. And sec square x will be 2 sec x, and sec x will be sec x tan x. So this is 2 sec square x, and then we have tan x. Okay. So this cos square x we want, and we see sec square on the right hand side. So if we bring this sec square x on the left hand side, it will be cos square x. So we are trying to make this equation which the examiner would have wanted from us. So sec square x, if it goes on the left hand side, it will be cos square x. Eventually this sec square x first will go to the denominator, then it will go to the numerator, and then it will be cos square x. Now what do we have here? Cos square x d2y by dx2 we have already got. D2y by dx2 cos square x. On the right, we still have to find out the 2y minus 2x. That is, if you take this minus 2y plus 2x on right hand side, we would need minus 2x and plus 2y. Now this is 2 tan x here. So the first equation from where we have started, you can write tan x as you take x on other side, so it will be y minus x. When you multiply it by 2 both sides, it will be 2 tan x equals 2y minus 2x. So in place of 2 tan x, you can simply write 2y minus 2x. In place of 2 tan x, just write 2y minus 2x. So now bring it here. So cos square x d2y by dx2 plus, let it be negative because the equation has negative first, so minus 2y plus 2x is equal to 0. So this equation is matching clearly, and how we are going to write? The way we are going to write is being provided to you on the left hand side, that is the actual solution with all the content which you have to write. This is differentiating, dividing both sides, hence proved like that. Next one is y equals x cube log x. Prove that d4y by dx4 is equal to 6 by x. So you have to differentiate this 4 times. 4 times. We have y is equal to x cube log x. So this is differentiation 4 times. So dy by dx will be equal to, we have x cube log x. So x cube log x is 1 by x plus log x. X cube will be 3x square. This is the first differentiation. X, you can cancel this out, x with x square. So you have x square here plus 3x square log x. And then we have d2y by dx2. So second differentiation we are doing now. So x square will be 2x simply plus 3. Now x square log x will do it somewhere else and put the result here. So x square will be x square and log x will be 1 by x. So I'm doing it separately, right? So x square into 1 by x plus log x, let it be here. X square differentiation is 2x. So you get this, you can cancel. This x and x square can be cancelled. So you get x only here plus 2x log x. So inside this bracket you have x plus 2x log x. And 3 is outside, so multiply it and write. So you get 3x plus 3 to the 6x log x. So this 2x plus 3x will be equal to 5x, 5x plus 6x log x. So on the left, I've tried to show you the solution that you can follow if you are well aware of this solution. Now for those who are actually interested in the solution, let us proceed for 5x plus 6x log x. Now this will be the third differentiation which we are going to do now. So 5x plus 6x log x, there will be one more after this. So 5x differentiation is 5, 6, x log x will do it separately. So x log x is 1 by x plus log x, differentiation of x will be 1. So 1 plus log x you will get 5 plus 6, 1 plus log x. So 5 plus 6, I'm multiplying 6 inside. So 6 plus 6 log x, you get 6 plus 5 is 11, 11 plus 6 log x. So this is d3y by dx3, now d4y by dx4 we have won. Differentiation of constant is 0, 6 log x is 1 by x, so you get 6 by x finally. So this is the fourth order derivative or higher order derivative of function y equals x cube log x. You have to write it like this, which I am showing you right now. Next one is, if y is equal to log sin x, prove that d3y by dx3 is equal to 2 cos x cosec square x. Cosec cube x. Oh, it is cosec cube x. So this differentiation of all the trigonometric and inverse trigonometric log e to the power x, you should know all of this, then only you will be able to solve these kind of questions. So we have y is equal to log sin x, so 3 times we are going to differentiate it. So dy by dx will be equal to log of anything will be 1 by that thing, so 1 by sin x. So sin x will be cos x. Cos x by sin x is nothing but cot x. So dy by dx is this. Now let us differentiate it again. d2y by dx2, cot x is minus cosec square x. This is d2y by dx2. d3y by dx3, differentiation of this. So this is, if assume it to be x to the power n, differentiation of x to the power n is nx to the power n minus 1. So nx to the power n minus 1 differentiation, you get twice of cosec x, and then you have cosec x cot x. The differentiation of cosec x is cosec x cot x with a sign. I'll just show you, and those who really want to see how you have to write, I'll show you the solution just now, but this is the third differentiation. So this is minus 2 cosec x, and as I said, cosec x will be differentiating to cosec x cot x with a sign. So minus minus will become plus. We have cosec x already, cosec x cot x, let us write. So you have twice of cosec square x cot x, twice of cosec square cot x. Okay. But the thing is, the answer is not saying that. Cosec square x cot x, so the best way is to write in the form of sin and cos. So when we can write it in the form of sin and cos, then we can get some sort of cos x and cosec cube x. So the first or the basic method is to write this cot x as cos x by sin x, cosec x as 1 by sin square x. In this way you can proceed. I'll just show you that way. But it will be better to do it this way only, which I am doing. So twice of, so as I said, cot x is cos x by sin x. Cosec square is 1 by sin square x. So we are getting cosec cube x. Why? Because cosec square x 1 by sin x can be taken above in the numerator. So cosec square x into cosec x is cosec cube x. And you already have a cos x. Okay. So 2 into cosec cube x and cos x we have got. See, normally in this question what happens, we will find out 2 cosec square x cot x and we'll say, oh, this is the answer. And we'll just go forward. But it is not the case. The case is you can easily find out 2 cosec cube x cos x either by converting this into cosec x as 1 by sin x. Likewise, y is equal to 2 sin x plus 3 cos x. You have to show that d2y by dx2 plus y is equal to 0. So y is nothing but 2 sin x plus 3 cos x. So we can anticipate that differentiating will give you y back, that is 2 sin x plus 3 cos x back somewhere. So y is equal to 2 sin x plus 3 cos x. Let us divide it. Dy by dx, it will be 2 sin x will be cos x plus 3 cos x is minus sin x. So I'm bringing this negative here. 3 cos x is minus sin. So 2 cos x minus 3 sin x. Now d2y by dx2 will be 2 cos x will be minus sin x and minus 3 sin x will be cos x. So it will remain as negative. 3 sin x will be cos x. Now you just take the negative sign outside. What do you see? What do you find out? 2 sin x plus 3 cos x, and which is eventual. What is y only? I mean, we have started with this, eventually we found the same stuff. You have negative y, you can replace it by negative y, and this negative y can be brought to the left hand side and it will be d2y by dx2 plus y is equal to 0. This is your final answer. Okay, this is the step-by-step way of doing it. You have to do it like this, absolutely same. This is your, for exam purpose or your classwork purpose, the logic is being told by y is equal to log x by x, d2y by dx2. So we have y equals log x by x. Now there are two methods to do it. Just apply the quotient rule, or you say it is log x multiplied by 1 by x. So you can apply the product rule also. So if you have numerator and denominator, quotient rule. But if you have numerator and denominator, you can use the numerator as it is, but the denominator will be 1 by that denominator can be taken as the second function. This is up to you how you are going to solve it, which is in which way you are comfortable. You have to follow that. So I am following the product rule. Log x, 1 by x differentiation is negative 1 by x square plus 1 by x. Now log x will be 1 by x differentiation. So this is going to be, this is 1 by x and 1 by x will be 1 by x square. Now minus sign, it will be log x by x square. Now you can take x square in the denominator common. 1 minus log x divided by x square is your dy by dx. dy by dx. Now we have to do d2y by dx2. So you have to differentiate it twice now. d2y by dx2 will be what? So again we will do it. I will do it using the product rule. It's up to you. See, the solution which I have provided is using the quotient rule. But the better way is to do it using the product rule if you are comfortable with. So 1 minus log x by x square. So we'll take the first function as 1 minus log x. The second function is 1 by x square. So d2y by dx2. This is equal to, previously I have done the same question using the quotient rule. That is why I am offering you this solution with the product rule. So 1 minus log x, 1 by x square differentiation will be what? See, x square, if it goes up to the numerator, it will be x raised to the power minus 2. X raised to the power minus 2. Now, when we differentiate this, it will be n x to the power n minus 1, that is negative 2. X to the power minus 2 minus 1, that is minus 2 to the power x to the power minus 3. And then we have a plus sign here. 1 by x square will remain like that. 1 minus log x will be differentiating. 1 minus log x, 1 will be 0. Minus log x is 1 by x. So negative 1 by x. So we have this. So I'm bringing it in front. Minus 1 by x cube. Here again we have a negative. So minus 2. 1 minus log x. And this is divided by x cube. Now you can take the x cube as the denominator. You have negative 1, negative 2. If you multiply negative 2 inside, it will be negative 1. Minus 2 into 1 is minus 2. And minus minus is plus, so you have 2 log x. So minus 1 and minus 2 will give you minus 3, negative 3. And then we have this 2 log x. So 2 log x minus 3 divided by x cube. This is b d2y by dx2 you will get. And this is the way you have to write. And there are other ways also which I just indicated. And quotient rule and product rule both can be applied. But ultimately you have to divide it or differentiate it twice. A is a sec theta, b is y is b tan theta, a is x a sec theta. d2 by dx2 is b raised 4 divided by a square y raised 3. Now if I observe clearly, if I want you to observe clearly that there is no x on the right hand side. So there will be certain way or a step where we are going to eliminate certain things and put certain things. But this is a parametric kind of question. So this will be done in the way I have indicated you just now. If you are able to do it by yourself, you can just follow these steps and you can do. But For those who want to understand, x is equal to a sec theta, y is equal to b tan theta. Before going to d2y by dx2, we have to find dy by dx. So we'll do dx by d theta, that is, we'll differentiate with respect to theta. A sec theta is sec theta tan theta. This is dx by d theta. Dy by d theta will be what? B tan theta will be sec square theta. So in order to get d2y by dx2, you need to get dy by dx. How are you going to get dy by dx? See, dy by d theta divided by dx by d theta will give you dy by dx. You have 1 and 2, you have to divide this 1 with 2. So dy by d theta, dx by d theta. Now just divide these two. B sec square theta divided by a sec theta tan theta. Now you can cancel this sec. So it will be sec by tan. So you have b by a, and this will give you, see, sec is 1 by cos, tan is sin by cos, only 1 by sin will remain, that is cosec. So you have b by a cosec theta as dy by dx. Now you have to differentiate it twice. d2y by dx2 you have to find. So this is b by a cosec theta. d2y by dx2 we have to differentiate it. But there is only theta here on the right hand side. So in order to do d2y by dx2, we have to differentiate the cosec theta. But cosec theta doesn't have an x. So what do? We will differentiate cosec theta as it is, but we will also differentiate theta, considering the previous discussion we had. B by a cosec theta is simply minus cosec theta cot theta. You already know that. Differentiation of cosec theta is negative cosec theta cot. But since it is differentiation with respect to x and we don't have any differentiation on the with respect to this, we have to write this theta as d theta by dx. Now you come here. D theta by dx, you already have dx by d theta. So in order to get d theta by dx, you have to take the reciprocal of. So write everything like that. B by a minus cosec theta cot theta in place of d theta by dx. Just replace it by the reciprocal of a sec theta tan. So I am just writing it in the denominator. 1 by a sec theta tan theta. So this is what you got. Now the first way to solve this is using the sin cos terminology. Writing 1 by cosec theta. Cosec theta is 1 by sin theta. Cot theta is cos theta by sin theta. Sec theta is 1 by cos theta. Tan theta is sin by cos theta. This is the one way to do. But what do you see on the right? That is, what without doing this 1 by cos, cos by sin, all these. The best way is you see cot theta and tan theta, and you want tan theta on the right hand side also, because you know tan cube theta, ultimately I'll just tell you y is equal to b tan theta. So there is a possibility of rearranging y equals to b tan theta and putting it here, right? So coming back to this cot theta and tan theta which I was just telling you about, cot theta can be written as 1 by tan theta, then tan theta and tan theta can be multiplied, it will be tan square theta. From this cot theta and tan theta we got this, okay? So you get cot and tan as 1 by tan square theta. How about this cosec theta and sec theta? Cosec is 1 by sin and sec will be 1 by cos. So ultimately you are going to get one more tan theta in the denominator. So you have tan cube theta in the denominator. So let me write the final thing. It will be b by a, and one more a is there because we have a sec theta tan theta which we bought in place of dx by dt. So it will be minus b by a square. Then we have 1 by tan cube theta d2y by dx2. Still we haven't got the result. d2y by dx2 is something else. So this tan theta has to be eliminated, and you see there is y also on the right hand side, so we'll use this one, the second one, y equals to b tan theta. So in place of tan theta, now you can replace it by y by b. Since you have tan cube theta, you can write tan theta as y by b, tan cube theta is y cube by b cube. So minus b by a square, you have tan cube theta, it is y square by b square. So when it is reciprocal, when it goes up, it will be b cube by y cube. So b cube by y cube it will be. Now write b cube by y cube here, b cube by y cube. Now b into b cube is b raised to the power 4, it will be raised to the power 4, a square and y. This is the result, alright? So this is a very different kind of question with parametric inside. So we have the parametric form, that is, we don't have x or y on the right hand side. We have a different variable. For example, here t, somewhere we have seen theta. So what we'll do here is, in order to find out the double derivative, or you can say the higher order derivative, we have to take x like this as a cos t plus t sin t. Now there is a mistake here. But I'll just tell you later on. So dx by dt, you must understand how we are going to approach. So dx by dt is a, cos t is minus sin t, and t sin t, I will do it separately. Let us do it here, t sin t. So when we do the dx by dt, we are doing it respect to t. So t will be differentiated in the way the x is differentiated. So we have t, sin t is cos t, plus sin t, differentiation of t is 1. So we have t cos t plus sin t. We can just directly write this, t cos t plus sin t, and we can see sin and negative sign can be cancelled. So you have a t cos t. Now coming to the y part. Now you see this is a sin t minus cos t. So there is something here which is lacking, but let us do it. If this question comes, then you can always do like this. A sin t is cos t is minus sin t. And so when you divide these two, that is what you have to do is dx by dt, dy by dt you have to do. In order to get dy by dx, you have to divide these two in order to get dy by dx, and then you can go for d2y by dx2. So when you do this d2y by dx2, that is the second derivative of dy by dx, you need to have dy by dt, dx by dt. But if you divide these two, at cos t and a cos t is plus sin t, there is no way you are going to get sec cube t by at. We can see here. So there is a slight change. I will add one thing and you will see that this question will be easily solvable and this result can be achieved. So let us do it like this. We have to introduce certain thing because we need to be sure that these two are similar. That is a cos t plus t sin t. So you need to have a sin t minus t cos t. Minus t cos t. So there will be an equilibrium now. There will be a possibility of proper solution now, because questions are meant to be solved. They are not meant to be to get the student to stuck somewhere. So now let us do it like this. A sin t minus t cos t. So a sin t is cos t, differentiating now. T cos t differentiation is t cos t is minus sin t. Then we have cos t here. Differentiation of t will be 1. So you have cos t minus t sin t. So it is negative, so I'll just change the sign. It will be plus t sin t minus cos t. Here again the cos t and minus cos t cancels. Now you see that at cos t or dx by dt, dy by dt has come as at sin t. This seems quite relevant now. Okay, now dy by dx, you know already how to find it out. Dy by dx is dy by dt divided by dx by dt. So at gets cancelled. Sin t by cos t is tan t. So dy by dx now is tan t. So d2y by dx2 is what? Tan t sec square t. But you are not differentiating with respect to t. You are differentiating with respect to x. So you have to differentiate t again. So you have to write dt by dx also. So dt by dx. But dx by dt already is with us. Dx by dt we have already computed as at cos t. So we have sec square t dt by dx, that is at cos t has to be taken into the denominator. Finally you have sec square t at cos t. This cos t, when it goes up, it will be sec cube t. So you have sec cube t in the numerator and a t in the denominator. The final answer we have got. It is between 0 and pi by 2. Sec cube t by 8. There is a slight change which I did in this question. It is t cos t. Y equals e raise x cos x. We have to prove that d2y by dx2 is 2 e raise x cos x plus pi by 2. So y is this thing, dy by dx will be ex, cos x will be minus sin x. Then we have cos x, e raise x will be e raise x. We have this. So then there is nothing we can do right now here. So we will just go for d2y by dx2. d2y by dx2, we have ex sin x. Differentiation of this. Separately, I'm doing the two terms separately, right? So ex sin x will be cos x. Then I'm applying the product rule. So sin x and e to the power x. Just write it here because it was negative. So I'm putting a negative sign also. Minus e raise x cos x minus sin x e raise x. Cos x into e raise x. So we'll do it again, means separately. So ex cos x. So ex cos x is minus sin x. Then we have cos x. E raise x is e raise x. So let us put it here. So we have e raise x cos x first I'm writing. Then we have a negative e raise x sin x. Okay. Now see the terms which can be cancelled. Those terms which are similar but with different sign can be cancelled. So we are cancelling e raise x cos x here. Then we have e raise x minus e raise x sin x 2 times. So we have minus 2 sin x e raise x. Now the problem is we don't have a cos here. We need to have a cos here. We have 2. We have e raise x. So minus sin x has to be converted to cos x plus by 2. But by trigonometric discussions we had earlier, we know already that cos 90 plus theta is minus sin theta. So cos x plus pi by 2 is negative sin x. So it will be 2 e raise x cos x plus pi by 2, because cos 90 plus theta is minus sin theta. Okay. So this is how you are going to write it. This is the whole steps you have to follow. Logic I have already told. So this is a parametric form, and this kind of questions we have already taken. This is how you are going to proceed. It's a very easy solution. That is, the question is not having any kind of say some tricks or some special things. At theta equals pi by 6. So we will be using some certain sine and cos value. Pi by 6 is nothing but 30 degree. If you multiply it by 180 by pi, you will get it in degrees because pi by 6 is in radians. So when you multiply it by 180 by pi, you get 30 degree. And we are going to use this 30 degree sine and cos. That's why I presented you with the table also. Same thing we have to do. We will do it in the way of parametric solution. We'll find out dx by d theta, then dy by d theta, then we'll divide them. That way we'll get dy by dx. Then we'll again differentiate it to find out d2y by dx. Okay, so x is equal to a 1 minus cos cube theta. So dx by d theta is a, this is 0, 1 is 0, differentiation is minus. Cos cube theta can be considered as x to the power n. It will be n x to the power n minus 1 first of all, that is 3 cos square theta. As I said, x to the power n, differentiation is nx to the power n minus 1. So you'll get 3 cos square theta, and cos theta will be minus sin theta. You have to differentiate cos theta again. Finally, you will get 3 cos square theta, and you have a minus sin theta here. So minus you can take outside. So 3a sin theta cos square theta dx by d theta. Now dy by d theta. So what is y here? Y is equal to a sin cube theta. So dy by d theta will be a. Again, it can be considered sin cube as x to the power n. So 3 sin square theta, then sin theta differentiation will be cos theta. So 3a sin square theta cos theta, or 3a cos theta sin square theta. First of all, we have to find out dy by dx. Dy by dx will be, it will be dy by d theta divided by dx by d theta. So dy by d theta we have already found out. Let us divide dx by d theta. That is, this has to come in the denominator. So we have 3a sin theta cos square theta, and we have this cos gets cancelled, and then one side minus side cancelled, 3a gets cancelled. So you will just get dy by dx as tan theta. Okay, so dy by dx it is. So you need to find out d2y by dx too. So tan theta is what? It's sec square theta simply. But still, you will not stop here. You have to do d theta by dx also, because you are not differentiating with respect to x. Here, actually you are differentiating with respect to x, but there is no x on the right hand side. That's the situation. Now you already know dx by d theta we already computed. So this d theta by dx, actually dx by d theta has to be written, and that will go into the denominator. So you have sec square theta divided by 3a sin theta cos square theta. So you have 3a sin theta cos square theta. Now cos square theta goes up, it will be sec square theta. You already have a sec square theta, so sec square theta will be sec to the power 4 theta. You have 3a sin theta in the denominator. Now sec raise 4 theta. What is sec 30 degree at pi by 6? At 30 degree we have to find out. So sec to the power 4 30 divided by 3a sin 30. Sec theta is 2 root 2 by 3, or if you are well versed with cos 30, that is root 3 by 2, you can take directly that. You have 2 by root 3 whole power 4, and you have this 3a. So 1 by 3, I am taking it outside. We have sin 30 degrees. Sin 30 degrees is simply 1 by 2. So this 2 to the power 4, 2 is also in the denominator. It goes up. So 2 to the power 5 it will be. So 2 to the power 5 divided by root 3 to the power 4. 2 to the power 5 is 32. Root 3 to the power 4 is what? Root 3 into root 3 into root 3 into root 3. Root 3 square is 3. Root 3 square is 3. 3 into 3 is 9. So you get 32. This is 3 already. So 9 3s are 27. So you have 32 by 27, and you have a in the denominator. So this is what we wanted, and this is what we achieved. So if you are really writing it in your copy or writing in your exam, then this is the way you have to go about. Next one is again the parametric form. This question, I hope you have a better idea now. You already seen that, how to work along with this, but if you want, we can go ahead with the solution. And if those who have already understood, they can just go forward, but we'll do this one. X is equal to a theta plus sin theta. Dx by d theta will be a, theta will be 1. Theta is of course considered as x here, plus cos theta. Now dy by d theta we have to find. So y is already given as a 1 plus cos theta. A 1 will be 0. Cos theta is minus sin theta. You will get minus sin theta here. You have minus a sin theta. So this dy by d theta also we have got. Now dy by dx, in order to find out, you have to find out dy by d theta divided by dx by d theta. You have to divide these two. So you have to divide this a 1 plus cos theta here. So minus a sin theta will be numerator, a 1 plus cos theta in the denominator. Okay. Now this next thing is you can solve it, because ultimately you have to find out d2 over dx2. This is just, we have cancelled a. So minus sin theta 1 plus cos theta. So we have to find out d 2y by dx2 we will find out in the normal fashion, but we have to once again write this d theta by dx, and that will be coming from the second line which you see here. So I'm just differentiating it using the quotient rule, and this you already know, 1 plus cos theta square in the denominator. First we'll take 1 plus cos theta, sin theta will be cos theta, then we have sin theta, and 1 plus cos theta differentiation is 0 minus sin theta, that is the sign will be like this, because in the quotient rule, in the numerator between the two terms, negative sign comes. You have to be very careful about this, because the sign changes all the solution, because sign has to be properly seen. So what will be the result here? You will get something here. See, sin theta is the differentiation of this, minus sin theta is the differentiation of 1 plus cos theta. But sin theta is already there in the numerator. So you will have a sin and sin as the second term. So you have minus cos theta, minus cos square theta, and then we have minus sin square theta. How does this minus sin square theta come? Because 1 plus cos theta differentiation is minus sin theta, but you already have a sin theta. The sin side becomes sin square, and you have a negative sign in between. As I said, there is a sign in the quotient rule, always the sign between two terms is negative. So finally we got minus cos theta, minus cos square theta, minus sin square theta. But we can sense that we are getting an identity here. Sin square theta plus cos square theta is 1. That we can easily visualize here. So if you take a negative common from each term, means all of the term has negative, of course. So when you take minus negative out of it, you will get cos theta plus cos square theta plus sin square theta, and sin square theta plus cos square theta is what? 1, right? So you have minus cos theta. You can take minus common here, cos square theta plus sin square theta it is, and sin square theta plus cos square theta is 1. So you get minus cos theta minus 1. So minus, if you take outside, it will be 1 plus cos theta. So what do we get? Minus 1 plus cos theta divided by 1 plus cos theta whole square. And now you have d theta by dx also. Because as I said, dy by dx is not we are not differentiating the right hand side with respect to theta, it is with respect to x. Now since we have no x on the right hand side, you have to write d theta by dx. So finally you have minus 1 by a 1 plus cos theta whole square. Okay. So what can we do here? There is no cos on the right hand side of d2 by dx2. We already computed d2 by dx2. So we will get it from y. Y is what? It is a 1 plus cos theta. Y is a 1 plus cos theta. In the denominator, if I multiply a in numerator denominator, you will get a square 1 plus cos square theta. But a 1 plus cos theta is already y. So a square 1 plus cos square theta will be y square. So in place of a square 1 plus cos square theta, you can write y square. So you will get minus a divided by y square. So I am suggesting from y we can get y square, and you get minus a by y square. Okay, this is also a question which is quite similar to this one. So we have x equals a theta minus sin theta, dx by d theta will be a, theta will be 1, sin theta will be cos theta. This is dx by d theta. What is dy by d theta? You know already, y is given here, a 1 plus cos theta, so I am differentiating directly. A 1 is 0 and cos theta will be minus sin theta. Now this is minus a sin theta. So in order to get dy by dx, you need dy by d theta divided by dx by d theta. So this gets cancelled. You have minus sin theta divided by 1 minus cos theta. This is dy by dx. This question we have already done just now. Remember, there we just replace this y with a square 1 plus cos square theta. Remember, 1 minus cos square theta, 1 plus cos square theta, like that. But here you have d theta by dx also. So d theta by dx, d2 by dx2, when you do, you have to have d theta by dx also, which you see here. So I hope you'll be able to solve it, because we have come down to the same question. So this is also the same thing. Finally, when you have gone to d2 by dx2, that is, you have achieved d2 by dx2, you just have to replace it by pi by 2. Since we have done already a question where we replaced x as the theta by pi by 6, here you have to replace theta by pi by 2. So the procedure you have already understood. X is a 1 minus cos theta, y is equal to a theta plus sin theta. So dx by d theta is a, 1 will be 0, cos theta is minus sin theta. So you have minus minus plus. So you will get only a sin theta here. dy by d theta will be a, theta will be 1, sin theta will be cos theta. This is dy by d theta. Now you want dy by dx. So a1 plus cos theta divided by a sin theta, it will be dy by dx. A gets cancelled here, 1 plus cos theta by sin theta. So dy by dx is 1 plus cos theta divided by sin theta. So now d2y by dx2, we'll find out d2y by dx2. So I'm doing it using the quotient rule. You can do in whichever way you want. So it will be sin square theta, sin theta will be like this. 1 plus cos theta is 0, cos theta will be minus minus sin theta, so 0 minus sin theta it will be. I am differentiating 1 plus cos theta. Minus 1 plus cos theta will be same here, sin theta will be cos theta. So numerator I am doing, it is going to be minus sin square theta here. Here you have cos theta, I am multiplying cos theta inside, minus cos theta and minus cos square theta. So this question we have already done, sin square theta, cos square theta, we see that it is going to be 1 eventually. The numerator I am just doing right now, minus sin square theta and minus cos square theta, and here minus cos theta. You can take minus common from everywhere, but sin square theta plus cos square theta, we know it is already 1. So in place of minus sin square theta plus cos theta, it will be negative 1. So this is going to be negative 1 minus cos theta. So you can sin square theta in the denominator also. Okay. Now there is one thing. See, when we differentiated it dy by dx2, we have done the d2 by dx2. But still we have d theta by dx because we are differentiating with respect to x, not with respect to theta. Hope you got the idea. So d theta by dx it will be. D theta by dx is a sin theta. So what do you get? Minus 1 plus cos theta. I've just taken minus common from the numerator. Sin theta and a sin theta was in the denominator. You will get a sin square theta. So you have sin theta already, and then d theta by dx, or you can say dx by d theta is a sin theta, denominator a square sin square theta. So a sin cube theta, sin square theta into sin theta will be sin cube theta. So let us see. Remember cos 0 is 1, so cos pi by 2 will be 0. Similarly, so just put this cos pi by 2 as 0 here. So 1 plus 0, a, and you know sin pi by 2 is 1. Sin 0 is 0 and sin pi by 2 is 1. So you get in sin cube theta, you just replace it by 1 cube. So you have minus 1 by a. Minus 1 by a is the answer. See? Okay. So this question is also almost similar to the question we have been doing just now. 2-3 questions we have already covered. Same thing you have to do. I hope you'll be able to solve it. Replace finally by theta equals pi by 2. Now we have here x equals cos theta, y equals sin cube theta. So there is an equation which we have to prove. So we'll find out dy by dx and d2y by dx2. Y is already there with us. So those who want to do by themselves, this is a step-by-step reference. And those who want to understand x is equal to cos theta, dx by d theta will be what? It will be cos theta will be minus sin theta, negative sin theta. What is y? Y is sin cube theta. So this will be dy by d theta, 3 sin square theta, and sin theta will be cos theta, differentiation. We need dy by dx. How do you get it? Dy by dx. So we have to divide this. Dy by d theta divided by dx by d theta. So sin you can cancel. You get minus 3 sin theta cos theta. Now double differentiation has to be done. d2y by dx2. You can call it as y dash or y1 also. So d2y by dx2 minus 3 you will deal it with later. This is sin theta, cos theta is minus sin theta, and cos theta here, sin theta will be cos theta. Now there is one thing left, I'll just tell you in a while. So we have minus sin square theta plus cos square theta, and you already have a negative 3 in front. So let's multiply negative 3 inside. So this will give you 3 sin square theta minus 3 cos square theta. So d2y by dx2, when we did, we also want d theta by dx because we are differentiating with respect to x, and there is no theta, there is no x on the right hand side, it is actually theta. So d theta by dx is basically minus sin theta in the reciprocal form, because minus sin theta is dx by d theta. We need d theta by dx. So you can divide the whole content by minus sin theta. You have a y here. So you have y is sin cube theta. Then we have d2y by dx2. So this is going to be 3 sin square theta minus 3 cos square theta divided by minus sin theta. Next one is dy by dx whole square. So dy by dx already found. It's negative 3 sin theta cos theta. Just square it. So it is going to be minus 3 is 9. So sin square theta cos square theta. So we can cancel one sign from here. So sin and sin get cancelled. Only sin square theta will remain in the numerator. Alright. So we see that we have a negative in the denominator. So I've just changed the sign in the numerator. Sin square theta here. Also we have 3 here. So if you take 3 sin square theta from both the terms, I'm taking 3 sin square theta from both the terms. What do you get? Because we want 3 sin square theta, that's why I did it. Minus sin square theta will remain inside, plus cos square theta, because 3 is already been taken. And 3 3s are 9, so only 3 will remain. 3 sin square theta, cos square theta. Now what do you see here? It is sin square theta is already been taken, so I have to cancel it out. This is already been taken, so we don't need it anymore. It's already in the front. So we have cos square theta plus 3 cos square theta, and that will give you 4 cos square theta. 4 cos square theta. Okay, so this is 4 cos square theta, because cos square theta plus 3 cos square theta is 4 cos square theta. 4 cos square theta minus sin square theta we'll have. And in the front we have 3 sin square theta. 3 sin square theta here. Now we have got 3 sin square theta, we have cos square theta, but there is no sin square theta on the right hand side. So sin square theta has to be converted to cos square theta, and we know that there is an identity sin square theta plus cos square theta equal to 1. So in place of sin square theta, we can always write 1 minus cos square theta. So we have I'm writing just C for cos square theta. So 4 cos square theta minus 1 minus cos square theta. So 4 cos square theta plus cos square theta is 5 cos square theta minus 1. This is 3 sin square theta. 3 sin square theta. This is going to be 5 cos square theta minus 1. This is the answer on the right hand side. This is the right hand side you got. Okay. Next one is y equals sin x. We have to prove that d2y by dx2 plus tan x dy by dx plus y cos square x equals 0. Y is sin x. So those who want to do by themselves, I'm just giving you a reference. But those who want to understand, let's go ahead. Is simply consider it as sin theta. So dy by dx, we have to find out. There is no parametric form, so we can just go ahead. Sin theta is cos sin theta. Cos sin x actually it is. Now we have to differentiate sin x also, that will be cos x. So this is dy by dx. Now d2y by dx2 we have to find out. This is the first term, this is the second term. So you have cos sin x, cos x differentiation will be minus sin x or negative sin x, then plus cos x will be here. Cos sin x is minus sin x, and then we have, I'll just put the negative sign, and then cos x, because sin x differentiation is cos x. So we have minus sin x and cos sin x. Please remember, the sin x is inside of cos. It's like a theta. Cos sin x. Here what do you get? So we have the cos, so it is going to be cos square, and sin x, as I said that I'm going to put negative in just a while, because the cos x differentiation is negative sin x. So we have here cos square x, and then we have sin x with a negative sign. Okay, so now just see what is being asked, what needs to be proven. The proving thing will dictate what we intend to change here or replace here. So as I said, this negative sign I just placed in between these two terms. So we have both the terms as negative here. d2y by dx2. So y is sin x. So wherever you get sin x, replace it by y. You already have a cos square x in front of it. So cos square x here, y into cos square x. Here, what do you see here? dy by dx is cos x into cos sin x. You don't have a cos x here. So let us divide and multiply this term with cos x, so that we get cos x into cos sin x. So we have minus sin x, cos sin x. So this cos x numerator, cos x is denominator, because we have introduced it, so we have to multiply numerator and denominator. So this will be dy by dx, and this sin x by cos x will be tan x. So it will be negative tan x and dy by dx. Minus y cos square x it will be. This is d2y by dx2. Now bring everything on the left, so that it makes a complete equation with a 0 on the right hand side. So when it comes on the left hand side, it will be dy by dx with a tan x. Here also you have y cos square x equals 0. So same equation. So the only thing here is to consider is how to get this tan x. So you have to multiply and divide it by cos x, this term which I am highlighting right now. That is how we get a tan x here. X is equal to sin t, y is equal to sin pt. So this has to be proven, which you see on the right hand side, equals 0. So to begin with, we are not aware how we going to proceed. So the procedure is simple. Whatever you want to do, you have to do dx by dt, dy by dt. You have to find out dy by dx, then you have to find out d2y by dx. So that is the whole procedure you have to see. And meanwhile, in the course of this solution, you will see the result will come. X is equal to sin t, dx by dt is going to be, sin t is cos t, y is sin pt, p is a constant here. So dy by dt will be equal to sin pt will be cos pt, and differentiation of pt, as I said, p is constant. We are differentiating with respect to t, so it will be only p outside. Now dy by dx. So dy by dx will be dy by dt divided by dx by dt. dy by dx will be equal to, you have to divide this, so I am just dividing it here only. So p cos pt divided by cos t will come, dy by dx. So dy by dx is achieved. Now this next process is to differentiate it twice so that we get d2y by dx2. d2y by dx2 is going to be, so we will do it using the quotient rule. You can adopt any rule you want. So denominator will be cos square t. So we have cos t here, cos pt is minus sin pt, and differentiation of pt will be p. This first p was already there, the second p has come after the differentiation of cos pt. Now second thing what we have to do, because we have just differentiated cos pt, so cos pt will remain like this, and differentiation of the second part, which is the cos t, will do, and p is already there outside, that is p is with both the terms in the numerator. So cos pt will remain like this, the cos t differentiation will be minus sin t, and since it is minus, I am making the sign as plus. You can write it as sin t. So d2y by dx2, it is in terms of t. We have differentiated, there is only t on the right hand side, so you have to introduce dt by dx also. So dx by dt is cos t, but we have introduced dt by dx, so we have to take the reciprocal of it and in the denominator. So cos t introduced, so cos cube t will be in the denominator. Let us write this p into pp square, cos t minus sin pt. Here we get plus p cos pt into sin t. So cos cube t, I am dividing it for both the terms, taking in the denominator. So we have this. Okay, now see the term y is sin pt. So wherever you see sin pt, replace it by y. One cancellation of cos t will happen. Cos t can be cancelled with cos cube t. So sin pt by cos square t, sin pt is y. So you get minus p square y divided by cos square t. I am having an eye on the solution, the final solution also. That's why I am doing all this, because you cannot just replace anything by anything. You have to see that it must lead to a result also. Now here we have x as sin t, so in place of sin t in the second term replaced by x. So p cos pt by cos pt, this whole term, p cos pt by cos t, if I take cos cube t as cos t into cos square t, p cos pt by cos t is nothing but dy by dx. So just write dy by dx. X was already there, as I said, x I replaced it for sin t. P cos pt by cos t is dy by dx. Then we have the cos square t in the denominator as in the first term basically. So you have cos square t in the denominator. Now we have d2y by dx2. So cos square t you have to take on the left hand side. But we cannot have t. We have to get rid of t. So cos square t is what? Sin square theta plus cos square theta is 1. So cos square theta will be 1 minus sin square theta. What is sin t here? Cos square t is 1 minus sin square t. So 1 minus sin square t. Sin t is nothing but x. So it is 1 minus x square essentially. So cos square theta is, or x is 1 minus x square. d2y by dx2 here, it is already there, minus p square y. So let us take it on the left, so it will be plus p square y. Then we have x dy by dx, because cos square t denominator is already being taken on the left hand side, cross multiplication. So this is the whole equation which we wanted to be proved. So what is x, what is y? Because this is a parametric form. First we have to do it parametrically, and then we have to go to the final solution. Next one is y equals sin inverse x whole square. We have to prove this. See, there is no p square, so the solution I'll just show you, because this is p square y, so there is slight change in the solution which I'll just show you. So y is equal to sin inverse x whole square, and there will be a root. So this is the actual solution. d2y by dx2, 1 minus x square minus x into dy by dx minus 2 equals 0 has to be proven. Alright. What you have to prove is somewhat not there. So dy by dx we generally write as y dash or y1. d2y by dx2 we generally write it as y double dash and y2. Alright. So whenever we write y dash or y prime, it is dy by dx, y double prime is d2y by dx. And we have to prove this, which I showed you in this solution. Not this term is of the previous question, which is replicated here. So there is a slight mistake here. I'm going to correct it just now. So dy by dx, you have sin inverse x to the power 2. It has to be treated just like x to the power n. So it will be 2 sin inverse x to the power 2 minus 1. That is going to be 1. So you have 2 sin inverse x. Now you have to differentiate sin inverse x also. It is 1 by under root 1 minus x square. You get 2 sin inverse x divided by under root 1 minus x square. 2 sin inverse x divided by under root 1 minus x square. This is your dy by dx. Now next thing is d2y by dx. So you can use a product rule or quotient rule which you want, but I'll do it I'm going to take it later. Sin inverse x 1 by under root 1 minus x square. So the first term, second term, product rule we will apply. Sin inverse x, this 1 by under root 1 minus x square square. Differentiation will be 1 by under root 1 minus x square. It is nothing but 1 by 1 minus x square to the power 2. 1 minus x square to the power half. When it goes up, it will be 1 minus x square to the power minus half. When we differentiate it, it is going to be minus half 1 minus x square to the power minus 1 minus half minus 1. That is going to be minus 3 by 2. Minus half minus 1, if you add, it is going to be negative 3 by 2. And then differentiation of 1 minus x square will be minus 2x. So this is the final result. So minus minus I am cancelling, 2 I am cancelling. It is going to be x in the numerator. Denominator, if you take this 1 minus x square to the power minus 3 by 2 in the denominator. So x, I am taking this 1 minus x square to the power minus 3 by 2 in the denominator. It is going to be 1 minus x square to the power 3 by 2. So this is the result of differentiation of 1 by under root 1 minus x square. So just let us replace it like this. X by 1 minus x square to the power 3 by 2. So it is going to be 3 by 2 plus. Now 1 by under root 1 minus x square already done. Now differentiation of sine inverse x, that is already known to us. 1 by under root 1 minus x square. Under root x into under root x is what? It is x. Root gets cancelled because the power gets half plus half is 1. So let us multiply this. It will be only 1 minus x square. This term sine inverse x is in the numerator. 1 minus x square to the power 3 by 2 is nothing but what? 1 plus 1 by 2. So you can write it as 1 minus x square into 1 minus x square to the power half. So this half is root only. 1 minus x square root. This is 1 minus x square, so you can write 1 minus x square to the power 3 by 2 as 1 minus x square into under root 1 minus x square. Since this 1 minus x square is there with both the term, as I said 2 I will take it later, so I have to introduce 2 here, 2 into both the terms. So this is d2y by dx2, which is y2, which is y double prime. This 1 minus x square, take this and bring it to the left hand side. So it is going to be 1 minus x square into d2y by dx2. Now this, see the solution, this has come, first part. Let us take the second part. 2x sine inverse x divided by under root 1 minus x square. We have already done dy by dx. So dy by dx is what? 2 sine inverse x divided by under root 1 minus x square. So 2 sine inverse x divided by under root 1 minus x square is nothing but dy by dx. So this term, these three terms is dy by dx. There is x here and other term, we can replace it by dy by dx. You can write it as y1 plus 2, 1 minus x square, y2. So I am taking everything on the left hand side so that we have a 0 on the right hand side. So 1 minus x square d2y by dx2. This goes here, so it will be negative x into dy by dx. I am replacing y2 by now d2y by dx2, y1 as dy by dx, minus 2 equals 0. So there is a slight mistake, you just ignore it, and the solution which is coming here hence above the hence proved is what we have actually proved. So whether you solve in any way, this equation is going to come. There is no replacement or trick. Y equals e tan inverse x. Now let me tell you that when you attempt this kind of question, you have to be well versed with the differentiation result. If you don't know the differentiation properly, you can head back, just revise it, and then come back here again. y1, y2 you already know. y1 is dy by dx, y2 is d2y by dx2. So we have y equals e tan inverse x. This is a kind of a simple question. You can just go ahead with the next question, but those who want to understand, let us do it. Y equals e tan inverse x, dy by dx is e tan inverse x, or because e to the power anything will be e to the power that thing only. Now tan inverse differentiation is 1 by 1 plus x square. So this is your y1, this is y2, d2y by dx2 we are going to do now. So this first term I am going to apply the product rule here. E tan inverse x, differentiation of 1 by 1 plus x square. Let us do it here. 1 by 1 plus x square, I am taking it in the numerator, which will be 1 plus x square to the power minus 1. It will be minus 1, 1 plus x square to the power minus 1, that is minus 2. And differentiation of 1 plus x square will be 2x. So we have 2 minus 2x divided by 1 plus x square whole square. This is going to be negative 2x divided by 1 plus x square whole square. So this we have done just 1 by 1 plus x square, 1 by 1 plus x square. Now differentiation of e to the power tan inverse x will be e to the power tan inverse means already done. Y equals e tan inverse x, differentiation is already done. So you can just place the result y1 directly here. E tan inverse x into 1 by 1 plus x square. So you have in the denominator 1 plus x square whole square in both the terms. But what we will do is, we'll see that where we can replace it by y1, that is dy by dx. We also have a y as e raised tan inverse x. Alright, this whole is y1, as we have just seen dy by dx is this term. Here also this whole, if you just write it as 1 plus x square into 1 plus x square, this whole term is what? It's just minus 2x dy by dx. I'm not writing 1 plus x square because I'm going to take this 1 plus x square on the left hand side. I'm just saying 1 plus x square is in the denominator, but we'll take it on the left hand side. Here also 1 by 1 plus x square remains. This whole term becomes dy by dx, that is y1. Now y2 is nothing but d2y by dx2. I'm taking this denominator 1 plus x square on the left hand side. So multiply cross 1 plus x square into d2y by dx2 is equal to, is going to be plus 2x dy by dx. This also goes dy by dx, but it will be negative, equals 0. So these are the common terms. Y1 is common term. 1 plus x square d2y by dx2, it is y2, and dy by dx is y1. You can, if you take dy by dx common, only 2x minus 1 remain inside. So your y1 2x minus 1 equals 0. This is the answer. Alright. If y is equal to 3 cos log x plus 4 sin log x, prove that x square, then we have the d2y by dx2, which we are calling as y2, and then we have the x of y1 we are calling it as dy by dx, and plus y, which is the original thing. So before we go ahead, we have y2, y1 and y. So we have to find the differentiation first, then the double differentiation, and once you do this, you will see that finally this will come. Okay, so those who want to do by themselves, this is the solution for them as a reference, because most of the things are not being given here. If I tell you or some instructor will tell you, then only you will be able to understand. So let's go ahead, because there are certain things in exam how you have to write that has also contains many marks or weightage. So you need to know how to write also. Y is equal to 3 cos log x plus 4 sin log x here. Then we have to find out the y1, which is the differentiation of this. Y1 is nothing but the differentiation. We have dy by dx it is. So 3 cos log x. So it will be minus sin log x, and differentiation of log x is simply 1 by x in the denominator. Then we have plus 4 sin log x. So it will be cos log x, and differentiation of log x will be 1 by x. So what do we get? See, this whole we just add minus 3 sin log x, and this we have plus 4 cos log x, and then we have x in the denominator. Why we have done this? Because this will be easier when we want to find out whether it is y1 or y, and because the equation we have to fulfill, so we have to do the y2, which is d2y by dx2, double differentiation, that is. So y2 will be equal to, we have, this is say p, this is say q, so p by q we have to do. So let us use the quotient rule to solve it. We have x here, so it will be x square. Here we write x, and the differentiation of this upper content. So minus 3 sin log x will be cos log x, and you know this, and differentiation of log x is 1 by x. Here we have, since I am having a view that this cos log x will give you minus, so I have written minus already. We have 4 sin log x, and then differentiation of log x is 1 by x. This x outside can be multiplied inside, so that we get rid of the denominator x in the numerator. That is, I am multiplying x inside. This is just one part. Okay, now second part is, just assume that x square is in the denominator. So we write this content, because we are following the quotient rule. So minus 3 sin log x plus 4 cos log x. Differentiation of x will be 1 only, and as I said, because of the lack of the space, this is x square in the denominator already. So this we already have, because y and y1 we have already computed. So I am taking negative outside for the first term. When we multiplied x, 1 by x and 1 by x already disappeared, and then we have this minus 3 cos log x minus 4 cos log x, and if you take negative also out of it, then what do you get? 3 cos log x, and then we have cos, I am writing in short so that we utilize the space. Then we have minus 4 sin log x. So this x square is in the denominator for all of it. Then this is negative. What content we have here? We have minus 3 sin log x plus 4 cos log x. They are same term. Okay, the numerator is same, so we have just divided them to make it easier. So we have minus 3 log, same thing is there is no differentiation as such. So now this negative can be taken out. This is 3 log cos x plus 4 sin log x. So if I just place negative here, it will be negative y. So the numerator is nothing but negative y, and then we have x square in the denominator. This is what? Minus 3. This is minus 3. Just see the y1. It is minus 3 sin log x plus 4 cos log x. If I write this x in the denominator, x square as x into x, this whole term is nothing but, already we have found the y1, so you can just write y1 here. This is your y1 divided by x. So this x square we have already used. 1x used, and was x is in the denominator. So we have started with d2y by dx2. So this is y2. What you will do now? Just multiply whole by x square. And once you multiply it by x square will be here, x square will be here, x square will be here. This becomes x square into y2, then this gets cancelled, minus y goes on the left with plus y. Here also x will remain, it goes on left, it will be plus x y1 equals 0. These two equations are similar, exactly similar. Yes, so this is how we go about it. There's a lot of replacements here. Next is y is equal to e raised to x ax plus b. We have to show y2 minus 4y1 plus 4y is equal to 0. y2 is d2y by dx2, y1 is dy by dx. So y is equal to e raised to x ax plus b. Then y1 will be equal to, we will do it using the product rule, e raised to x. Ax plus b differentiation is what? B is 0 and ax, so only x a will remain. Differentiation of x is 1 only. So e raised to x into a plus ax plus b, and then we have here ax plus 2b, and differentiation of ax e to the power 2x is 2x only, and then 2 comes. So how can we write this? A e to the power 2x plus 2 e to the power 2x ax plus b. This is y1, this is dy by dx. So let us go about finding the y2, then we'll come later to what kind of equation do we want, which is required in this example. So y2, we have a e to the power 2x differentiation. A is constant, so differentiation of 2x is 2. So we have 2a e to the power 2x as the first term. Coming to the second term, as I said, we already have a 2 here. E raised x 2x ax plus b is already been done. This is nothing but y. This is y only. And differentiation of y, that is y1, is already being done. So just take y1 and keep it here, or place it here. A e raised 2x plus 2 e raised to x ax plus b. So just multiply 2a e raised to x plus 2 to the 4 e raised to x ax plus b. 2a e raised to x, 2a e raised to x, this is 4a e raised to x. Then we have 4 e raised to x ax plus b. This is y2. So what all we have, what all we can do here? So I can write this, we already have a y2 and we have this 4y also. Now how this y has come? See, y is e raised to x plus ax plus b. So I have written 4y. What are we getting here? Are we getting something out of it? If not, then we'll apply some other tactic. y2 is 4y is also there, y2 is also there. So what is minus 4y? y1. Now let us go to y1. This y1, if you see this one, ax plus b plus e raised to x is what? This is y only. So y1 can be written as a e to the power 2x plus 2y. This equation I'm talking about, because I'm not getting to the solution. I'm not getting the solution. So I went again to y1, and y1 I found it to be a e raised to x, and this whole was y only. So I can just write 2y. That is a raised e to the power 2x can always be written as y1 minus 2y. So this is a raised e to x. What do we have here? 4 into a into e raised to x, that is 4 into whatever is on the left hand side from this equation we got. So it will be 4y1 minus 8y. So y2 will be equal to 4y1, we already have it, and minus 8y plus 4y is minus 4y. So 4y1 minus 4y we got. Now take everything on the left, So we have y2 minus 4y1 minus 4y equals 0. This is your final equation. So see, the solution which I provided you is different, and the solution which I did is different. That is why there can be multiple ways which we can go about it. It totally depends on your practice. Next one is x equal sine 1 by a log y. So this can be easily converted into a way which we have already done. So because differentiation of this will be a task, quite a task. So x equals sine 1 by a log y. Sine I'm taking here. It will be sine inverse x equals 1 by a log y. This a, let us multiply both sides by a. So we have a sine inverse x equals log y. Now we already know log. If I say log a equals b, the base is e. So it is nothing but a way of writing e raised b equals a. E to the power b is equal to a. This e a sine inverse x equals y. Same logic I have applied here. So when you have y equals e raised a sine inverse x, now we have already done a question like this, okay, and this you know how to get this. If you go to question number 20, 21 and the question before that, this kind of question is already been done, okay. So this is how you can go about, but this is y. So first you have to find out y using all the rules you have in your pocket after learning mathematics. Then y1, the differentiation of e to the power anything will be that thing only. So e to the power a sine inverse x, then the differentiation of a sine inverse x has to be done. So we have a, differentiation of sine inverse x is 1 by under root 1 minus x square. So what is this? Y equals e a sine inverse x. So this is what? This is nothing but y. So y1 is equal to ay divided by under root 1 minus x square. y1 is equal to ay by under root 1 minus x square. Okay. Now what we'll do here is, a will use it later. Just keep it aside. We have y by under root 1 minus x square. What you can do is, you can either apply the quotient rule or a product rule. It's up to you. So if you multiply this on the left hand side, y1 into under root 1 minus x square, you won't get anything. So let us differentiate it. So I'll apply the product rule here. First will be y. Differentiation of 1 by under root 1 minus x square is what? We've already seen that. So you can call it as 1 minus x square to the power minus half it goes into the numerator. It will be minus half 1 minus x square to the power of minus 1 minus half minus 1, that is minus 3 by 2. Differentiation of 1 minus x square is minus 2x. 2 gets cancelled, negative gets cancelled. So you have x. So 1 minus x square to the power 3 by 2. This is nothing but 1 minus x into under root 1 minus x square. Why? Because 1 minus x square under root is half only. Half plus 1 is 3 by 2. So finally we got 1 minus x square under root 1 minus x square. There is a x also, and there is a also. Please remember x and a. Now 1 by under root 1 minus x square, and then what do we have? See, differentiation of y is what? Dy by dx. Okay, so we are different. If you say dy by dx, you have to write just y1. So y1. So ay, x was also there, as I said. Now ay by under root and 1 minus x square is nothing but y1 only. So y2 is equal to y1, this whole y1, this y1 by 1 minus x square, y1 by 1 minus x square. Here you have this a y1 by under root 1 minus x square. So how to get this? So how can we get this? Okay, when we did that, this, if you remember, I told you x was already there. So don't forget about x, writing it as x. Here you have, so is this one. Let us introduce this again. Ay by under root 1 minus x square. So we have ay, I'm writing ay by under root 1 minus x square, under root 1 minus x square. In place of y1 I'm replacing ay by under root 1 minus x square. What do you get? A square y by under root get cancelled. You get 1 minus x square. Here we have x y1 by 1 minus x. So you have 1 minus x square multiplied on the left hand side, or all members you can multiply by 1 minus x square. So you have left in this x y1, and then we have plus a square y. Now bring everything on the left hand side. So you have 1 minus x square into y2 minus x y1 minus a square y equals 0. This is your final equation. So there are two replacement of y. We have y equals log x plus under root x square plus 1 whole square. Now this cannot be done directly, that is dy by dx and d2y by dx2. You'll see what we are going to do in order to get the answer. So we have log x plus under root x square plus 1. This is whole square, not only x plus under root x square plus 1 whole square, it is total whole square. You know, nx to the power n minus 1 is the normal differentiation. So this is whole square. Consider this x to be the log content. So we have nx to the power n minus 1, that is 2 log content to the power 2 minus 1, that is the same thing, log x plus under root x square plus 1. Now log is 1 by that thing, that is 1 by x under root x square plus 1. Differentiation x plus under root x square plus 1, x is 1 only, and differentiation of this under root x square plus 1 will be, we have already done that multiple times, x by under root x square plus 1. Now let us take the LCM here. So just multiply the cross, that is this, and write it in the numerator, and then multiply the denominator and write it in the denominator. So assume that this is the content we just got after differentiating x plus under root x square plus 1. This gets cancelled. So finally dy by dx is nothing but 2 log x plus under root x square plus 1, and this is divided by under root x square plus 1. Now you will attempt to do the dy by d2y by dx2. That is the normal thing which we will try to do. But this will not work. I'm telling you, believe me, I've tried it. So for that you have to square it, because you see that y is on the right hand side is log square. Alright, so we'll square this both sides. So I'm squaring it. So d2y by dx2 is nothing but we are squaring dy by dx whole square. So dy by dx I'm writing it as y1 square is 2 to the 4 log x plus under root x square plus 1 whole square divided by under root x square plus 1 whole square is x square plus 1 only. So let us multiply this, means cross multiply. So I'm taking x square plus 1 on the left hand side, x square plus 1, and then we have y1 whole square, and this is, now take this to the right side, will remain like that. So this is whole square, but this is y only. See, the log content square is nothing but y only. So y, it is 4y, you can replace it by 4y. Alright, so those who want to do by themselves, this is the only trick which has to be adopted, and that I already told. Rest you can always follow, but we will proceed by this this equation what we got, we have to differentiate it now. So I am differentiating both the sides, x square plus 1, this y1 whole square is 2y1, and differentiation of y1 is y2, that is d2y by dx2. So I'm writing it as y2, and then plus, now y1 whole square remain like that. Differentiation of x square plus 1 is 2x only. On the right we have 4y1, because differentiation on right also, cos 4 is constant, y differentiation is y1. So everywhere you find y1, actually 2y1 basically. So now divide everything by 2y1. Remember, divide everything by 2y1. So you'll get rid of 2, you'll get rid of y1 also. So you'll get x square plus 1 into y2 plus y1 into x equals 2, and that is what exactly we wanted to show. In the question, if you see, this is what we intend to show. So as I just suggested, you have divided everything by 2y1. So I'm eliminating the 2 also. In the answer it is 2. So that is how I got the idea. Next one is 1 plus x square, and this is d2y by dx2, y2 is d2y by dx2, y1 is dy by dx, then you have x here and 2. So this square is the only thing which you need to understand. Y equals tan inverse x whole square. This question we have already done. So I'm just going ahead. I've presented the solution if you want to do it again. Y equals cot x, this also we have done, but just to recall, because this is quite easy, so I'll just do it. Y equals cot x differentiation is minus cos x square x. So you don't have, there is no trick at all here. There is just differentiation twice. d2y by dx2 is what? It is, let it be minus cos x, 2 cosec x, and cosec x will be minus cosec x cot x. So minus will become plus. You have cosec x cot x here. So 2 cosec x cot x. So it will be 2 cosec square x. Then we have a cot x here. This is d2y by dx2. So this dy by dx is already there. It is minus cosec square x. So if you want to replace minus cosec square x, negative has to be taken in the left. So we have minus 2 in place of cosec square x. I am writing negative dy by dx. Then we have cot x here. So this is y only, cot x is y only. So d2y by dx2 is minus 2y dy by dx. Bring that right hand side on the left hand side. So it will be plus 2y dy by dx, and that is going to be equal to 0. Next one is find d2y by dx2. Y equals log x square by e square. Remember, e is a constant. So just treat it as a constant. So d2y by dx2, we just have to differentiate it normally, that we generally do. So dy by dx is log constant is 1 by that thing. So 1 by x square by e square, that becomes e square by x square. Differentiation of this, see, log again, then you have to differentiate x square by e square. So e square is constant, so let it be in the denominator. X square differentiation is 2x. 1 x you can cancel, e square you can cancel, it is 2 by x, and you have to now differentiate 2 by x. So d2y by dx2 is nothing but differentiation of 1 by x, and that is negative 1 by x square. So you have 2 minus 2 into 1 by x square minus 2 by x square is the answer. Y is equal to a e to 2x raised to x, and then we have plus b e raised minus x. So this kind of question we have already done, but there is a slight a tip here from my side. So I'll do it. Y equals a e 2x b e minus x dy by dx. Normally you will do. So it will be a e to e raised 2x, and differentiation of 2x is 2 only. Then we have here plus b. I know that negative is going to come, so I purposely placed negative here. B e raised minus x will be e raised minus x. Differentiation of minus x is minus 1. Okay. So we have 2a e raised 2x, and then we have minus b e raised minus x. This is your dy by dx. So d2y by dx2, let us do it normally. So 2a e raised to x, 2a is a constant, e raised to x will be e raised to x, and there will be 2 also. So there will be, the answer will be, or the first term will be 4a e raised to x. There is no tip till here. You just have to differentiate in a normal way, d2y by dx2. So you have 2a e raised to x is e raised to x, and then differentiation of 2x is 2. Then we have the second term, which is b raised e minus x. B is constant, e raised minus x will be e raised minus x, and differentiation of minus x will be negative. Alright. So I'm doing it the way I said, normal differentiation. So minus b e raised minus x, and then minus will be plus. So what do you get? You have 4a e raised 2x plus b e raised minus x. This is the normal differentiation. But we need to get the equation which is being suggested here. Show that d2y by dx2 minus dy by dx minus 2y equals 0. That we have to prove. So dy by dx is this one. How can we introduce dy by dx into d2y by dx2? So we'll try to get to, let us write this directly, because this is 4a e raised minus 2x e raised 2x, not minus 2x, plus b e minus x. But we have to get this. So how are we going to write? We'll write the dy by dx first. That is 2a e raised to x. 4a can be written as 2a e raised to x plus 2a e raised to x. How about b e raised minus x? It can be 2 b e minus x minus b e raised minus x. So if you subtract 2 with 1, it will be 1 only. Alright. So this one, the first term and the fourth term, we will write together, and this will be, I am taking 2 common here, a e raised 2x plus b e raised minus x. Now this is dy by dx only. Write dy by dx here. This is what? The original y. So 2y. So d2y by dx2 is equal to dy by dx plus 2y. So you get d2y by dx2. Now bring everything on the left hand side. It will be minus dy by dx plus 2y minus 2y equals 0. So this is what we have to prove, and this is the final answer. So this question already we have done. So this is the solution. You can always see. You have to prove this. So I hope you'll be able to do this. Y equals to cos inverse x. Find d2y by dx2 in terms of y alone. That is, whatever the answer comes, only y will be there on the right hand side. So we'll do it. It's quite simple, but as I said, there are some trick element which is there in this question. And you need to know the differentiation of trigonometric equations also. So dy by dx is simply minus 1 by under root 1 minus x square. This is very obvious. You know already, I hope. d2y by dx2 also same thing you have to do. It has to be minus 1, and this 1 minus x square under root in the denominator, when it goes up, it is going to be 1 minus x square to the power minus half. See, it goes up. So it is minus half. So there is a slight error. I'll just going to change it. So minus 1 minus 1. That is 1 minus x square to the minus half, and minus half comes in front. 1 minus x square to the power minus half minus 1 will be minus 3 by 2. So, and differentiation of 1 minus x square is going to be minus 2x. So as I said, it will be minus half in the front. There is a minus 2x. So minus will get cancelled. 2 and 2 will get cancelled. It will be x, negative x, because minus 1 is already there with d2y by dx2 as you see on the left. So you have, as I said, minus will get cancelled. This minus is redundant, so I'll just change it. So 1 minus x square to the power 3 by 2 will come in the denominator. 1 minus x to the power 3 by 2 is simply 1 minus x square into under root 1 minus x square, because 1 minus x square to the power 1 into 1 minus x square to the power half, 1 plus half is 3 by 2 only. Alright, so I just wrote it just to show you. We are not going to do anything with that. So finally you got, this is x divided by 1 minus x square 3 by 2. As I said, minus is not there because minus half into minus 2x was already, minus was cancelled. So there is a slight error which you can assume that I'm going to change just now. Okay, don't consider this negative x, it is plus x. Okay, so y is equal to cos inverse x. How do we write this? This is the trick. Okay, cos y equals to x. This means cos y equals to x. So in place of x you can always write cos y. In place of x write cos y. What to do with the denominator? See, x is cos y, so just replace x with cos y, so it will be 1 minus cos square. So it will be cos y divided by 1 minus cos square y, 3 to the power 3 by 2. 1 minus cos square theta is sin square theta. Now replace this 1 minus cos square by sin square, and since we have 3 by 2 as the power, so sin square to the power 3 by 2, 2 gets cancelled, and you get sin cube. 2 into 3 by 2 is 3 only. So you have sin cube here, sin cube. So you have finally minus cos y divided by sin cube y. There is a negative one. Alright, I'm just going to put this. Just consider this cos y. Sin cube y can be written as sin y into sin square y. Cos y by sin y is cot y, and this sin square y is cosec square y. This is your d2y by dx2. So this sign, as I said, will be negative because already I have showed you that this minus half into minus 2x gave us the positive sign. So there is only a negative on remain. So you have to put a negative in front of cot y into cosec square y. On the left hand side you have d2y by dx2. So we have finally achieved on the right whatever is there. It may be cot or cosec square, whatever it is, but with y only. There is no x on the right. This is the final answer. Y equals e raise a cos inverse x. So this question we have already done. You can just go to the previous questions and you see how we have done this. This question is also very easy. There is no trick involved. There is nothing special. But since it is a question which we have not done earlier, so we are going to do this. So y is equal to 500 e raised 7x plus 600 e raised minus 7x. So this is just a simple algebra multiplication. dy by dx is equal to, this is going to be 500. E raised 7x will be e raised 7x only, and there will be, when you differentiate 7x, it will be 7. 500 into 7 into e raised 7x. Then we have 600. I know that negative is going to come, so I already placed a negative in between. 600 e raised minus 7x, differentiation of minus 7x is minus 7 only. So 7 5 is 35, so you have 3500 e raised 7x. Then you have minus 7 6 is 42, 4200 e raised minus 7x. So this is dy by dx. You can call it as a y1. Y1 is dy by dx. Now y2 is d2y by dx2. So again differentiating 3500 e raised 7x will be e raised 7x. There will be 7 also, because 7x differentiation is 7 only. Again I know that negative is going to come, so minus minus plus 4200 e raised minus 7x. Differentiation of minus 7x will be minus 7. So just write minus, we have already handled, so into 7. So this is, you can just multiply these two. But before multiplying, why to waste energy? You know that 3500 into 7 is 24,500. 4200 into 7 is 29,400. But we need this in the answer, we need 49. So 49 into 500 is what? 49 into 500, I am multiplying it. You will get it, this as 24,500. If you multiply 3500 into 7, again you will get this only. 3500 into 7 is 24,500. So 49, if you take outside, you can have 500 inside. So e raised 7x. Similarly, the same fashion which I showed you, if you take 49 outside, it will be 600 inside. E raised minus 7x. This is y2, that is d2y by dx2. This is equal to 49. And what is this? This is y only. If you see, the question is y only. So 49y. This is how we prove it. Now this is x equals 2 cos t minus cos 2t. Y is equal to 2 sin t minus sin 2t. We have to find d2y by dx2 at t equals pi by 2. This is a parametric form. Now the solution is quite easy, and final the result, whatever it comes, you have to replace it by, wherever t is there, you have to replace it by pi by 2. Okay, so this is quite easy. Just differentiate and replace the value. So I am doing it. Dx by dt is minus 2 sin t minus sin 2t. Differentiation of 2t will be 2, and minus minus will become plus. Cos, differentiation of cos is minus sine, and 2t is already there, so 2 will come in front. Coming to y, 2 sin t minus sin 2t. So dy by dt is equal to 2 sin t is cos t, sin 2t is cos 2t, and differentiation of 2t is 2 only. So this is 2 cos t minus 2 cos 2t. Now we need dy by dx. This will be dy by dt divided by dx by dt. So just divide these two. dy by dt divided by dx by dt. So it will be 2 cos t minus 2 cos 2t divided by minus 2 sin t plus 2 sin 2t. Now first get rid of 2, because 2 is everywhere. So dy by dx will be equal to cos t minus cos 2t divided by minus sin t plus sin 2t. Minus sin t plus sin 2t. So this seems to be bigger, but you have to do normal d2y by dx2. You can use the rule, which is the quotient rule, but only one thing you have to remember, because everything is t on the right hand side. So whenever you differentiate, you have to introduce dt by dx, because you are differentiating with respect to x and there is only t on the right hand side. So once you differentiate this content which I placed inside the brackets, you have to introduce dt by dx also, right? Dt by dx will be here. So first differentiate this and then introduce dt by dx. I'm going to introduce dt by dx as of just now. So this in the denominator, you have minus sin t plus sin 2t whole square. So I'm just writing s for sin because we are short of space, and dt by dx also I am introducing right now. Dx by dt is minus 2 sin t plus 2 sin 2t. So when it becomes dt by dx, it has to come in the denominator. So I am writing it in the denominator. Minus 2 sin t plus 2 sin 2t in the denominator. Okay. This has been done. Dt by dx has been done. Now coming to the numerator, this will remain like this: minus sin t plus minus sin t plus sin 2t. Now we have to differentiate cos t minus cos 2t. Cos t is minus sin t. Minus minus become plus. So this is cos 2t is minus sin 2t, which minus minus became plus, and then differentiation of 2t will be 2. So this will be 2 sin 2t. 2 sin 2t. This is the first term. So this both just recheck, because there are so many sin and cos and negative and positive is going on. So there may be slight mistake. Minus. So this, just now we have differentiated cos t minus cos 2t. Now we have to differentiate minus sin t plus sin 2t. So we are going to replace cos t minus cos 2t just like that. And differentiation of minus sin t plus sin 2t will be done. So it will be cos t and plus 2 will come outside because 2t differentiation will be done. So we have cos 2t, twice of cos 2t. So what you have to do is, you don't have to solve anything right here. No multiplication, nothing. Just place t equals pi by 2. T is pi by 2. So we have already come up to this point. With this already I showed you. I need to tell you that what are the values here, because we are not just going to use the sin pi by 2 and cos pi by 2. We will be using sin pi and cos pi also, because we have sin 2t and cos 2t also. Remember, sin 0 is 0, so sin pi by 2 is 1. Similarly, sin pi by 2 is here what? 1. And then we have cos pi by 2 will be what? From the sine and cos will always be complementary to each other. Remember, cos 90 minus theta is sin theta. So if sin pi by 2 is 1, cos pi by 2 is definitely going to be 0. So cos 2t will also come. Cos 2t is what? 2 into pi by 2, that is cos pi. What is the value of cos pi? This is the main thing here. Cos pi is going to be, because cos 0 is 1, so you will be tempted to write cos pi also as 1. No, cos pi is negative 1. Cos pi, cos 180 degree is negative 1. This is the only thing which you need to remember. Otherwise your answer will not come, or you can say you will have a incorrect answer. So sin pi also we have got 0. So I am now placing value sin t, that is sin pi by 2, that is going to be 1, and since I have a negative sign we have negative, and 2 sin 2t, of course sin pi is 0, so I am placing a 0. Coming to negative sin t, that is sin pi by 2 we need, sin pi by 2 is 1, so you just write negative 1, and again sin 2 into pi by 2, that is sin pi is going to be 0, minus cos t, that is cos pi by 2, that is going to be 0, just write 0. Then we have cos 2t, so cos 2t, that is cos 2 into pi by 2, cos pi is going to be negative 1, and since you already have negative here, so you see it is cos t minus cos 2t, so you have negative with a negative, so it will be positive 1, this negative, plus 1, minus cos t, again cos t is cos pi by 2, so you can just write 0, minus 0 is no value, so we have cos 2t, twice of cos 2t, so that is going to be, because cos pi is minus 1, so minus 2 it will come. In the denominator again, just put all the values. You already computed all the values just now. So it will be minus sin t, so it is going to be minus 1, because sin pi by 2 is going to be 1. And since we have sin 2t as 0, then we have minus 2 sin t. Sin t or sin pi by 2 is 1, so it will be minus 2 into 1, that is minus 2. Plus, what is this? 2 sin 2t, sin pi is 0, so just place 0 here. Now there is just a computation, simple computation. So minus 1 into minus 1 is going to be plus 1. Then you have negative here. It will be 0 plus 1 is 1, and then we have minus 2, so minus minus become plus, so I have already placed a plus in between. So minus 1 square is 1, and then minus 2 we have, minus 2 here, so minus minus is plus, then we have a 2 here, and then you have negative 2 in denominator, so you have negative 3 by 2, this is d2y by dx2, alright, minus 3 by 2 is the answer. This question we are going to take in the next discussion. Till then, thank you so much, take care of yourself. This is R.D. Sharma solution, class 12, chapter 12, higher order derivatives, exercise is 12.1. If x is equal to 4z square plus 5, y is 6z square plus 7z plus 3, and this is a parametric form, that means you don't have x on the right hand side. So d2y by dx2, x is given as 4z square plus 5 and y is 6z square plus 7z plus 3. So let us differentiate it. Dx by dz will do. Now just assume that we are differentiating with respect to x, and z here is x. So this will be 4z square will be 2z. So 8z it will be plus 0. It's not plus 5, 0. I'll just change it. dy by dz is, again z square is 2z, 6 into 2z is 12z. Now here you have 7 and then 3 will be 0. This is going to be 0. So you have 8z and 12z plus 7. So this is dx by dz and dy by dz. Now we need dy by dx. That is y1 or y dash. So dy by dx can be computed by dividing dy by dz and dx by dz. Okay, dx by dz divided by dy by dz is nothing but dy by dx. So 12 z plus 7 divided by 8z. So we have to differentiate it again. So those who want to do by themselves, there is just a reference I have given, and those who want to continue, let us see. We have to differentiate it once more, and the differentiation can be done using the quotient rule. It can be done using the product rule also. So 8z square, I am doing it with quotient rule. So 8z square is 64z square. 8z will remain like this. Differentiation of 12z plus 7 will happen. This is 0. 12z is 12. So 12 will remain here minus. So we have this 12z plus 7, and differentiation of 8z is going to be 8. Is going to be 8. So just write 8 here. So 12 into 8 is nothing but 96 minus 8. This is again 96z. 8 into 12 it is, I have written 2 I guess, it is 12. So this is minus 56. One more thing is there. Tell me what is remaining. When you are differentiating dy by dx and there is no x, so you have to write dz by dx also. And what is dz by dx? It is the reciprocal of 8z. That is dx by dz is 8z. And you have to introduce dz by dx because you are not differentiating with respect to z. You are differentiating with respect to x. So then z will be a variable. Now I have divided this 8z multiplied. So the numerator will be negative 56. Denominator will be 64 into 8 into z square into z cube. We have minus 7 divided by 64z cube. So this is the answer. Those who are doing by themselves, this is the answer. If y is equal to log 1 plus cos x, we have to differentiate it thrice. dy by dx, d2y by dx2 and d3y by dx3. Let's see what we get. So there is one point where how this second part of the content which we have to prove, from where you will get it, that is the only discussion. Y is log 1 plus cos x dy by dx. So this will be anything with log comes down, that is to the denominator. So 1 by 1 plus cos x, differentiation of 1 plus cos x is going to be what? Differentiation 1 is 0, cos x is minus sin x, so you can write minus sin x here. This is dy by dx. Now d2y by dx2. So this in the denominator 1 plus cos x whole square, I am doing it using the quotient rule. 1 plus cos x whole square. Then we have 1 plus cos x here. Differentiation of minus sin x will be minus, I am writing here, sin x will be cos x. Now subtraction. Now minus sin x will be like this only. Differentiation of 1 plus cos x is going to be 1 will be 0, cos x will be minus sin x. So it will be negative sin x again. So let us multiply them properly. Numerator we have, just assume that we are multiplying 1 plus cos x by minus cos x. So minus cos x and then minus, this is minus cos square x. What do you get here? Negative cancels. You have a negative, sin and sin in sin square. In the denominator you will get 1 plus cos x whole square. Now you see, minus cos x minus cos square x minus sin square x, I am writing in short. So I am taking negative outside, it will be cos plus cos square plus sin square. Now cos square plus sin square is equal to 1. This is going to be 1. So 1 plus cos x, negative sign here. So the numerator is nothing but negative 1 plus cos x divided by 1 plus cos x whole square. Okay, you will be tempted to cancel it out. Okay. Minus 1 by cos x, but if you don't cancel it, there will be the dy by dx, d2y by dx2 will directly come, but let us see that we have d2y by dx2. See, this is d2y by dx2. Now we have to do d3y by dx3. So d2y by dx2 is minus 1 by 1 plus cos x. dy by dx is minus sin x by 1 plus cos x. So d3y by dx3 is negative 1 by 1 plus cos x. I am applying the quotient rule. So 1 plus cos x in the denominator with square. 1 plus cos x first, differentiation of negative 1 minus negative 1 into differentiation of 1 plus cos x. That is what we will do. And then the result, we will try to introduce the first derivative and second derivative here. Okay. So I am differentiating negative 1 by 1 plus cos x as I just suggested. 1 plus cos x whole square in the denominator, 1 plus cos x remain like this. D by dx of minus 1, it is a constant, so it is going to be 0. Minus, now 1. So minus 1 will remain like that. And then we have 1 plus cos x differentiation. 1 is 0. Cos x is negative sin x. Cos x is minus sin x. So just write minus sin x here. You write minus sin x. A minus become plus. So it will be negative only. 1 plus cos x will be 0 because it is multiplied by 0. Here we have minus sin x divided by 1 plus cos x whole square. Now you see here, we have negative 1 by 1 plus cos x, and this is d2y by dx2. dy by dx is minus sin x by 1 plus cos x. So this I am writing minus sin x by 1 plus cos x whole square as minus sin x divided by 1 plus cos x into 1 plus cos x into 1 by 1 plus cos x. Now I am introducing negative 1 numerator denominator. Why? Because we know negative 1 by 1 plus cos x is d2y by dx2 and minus sin x by 1 plus cos x is dy by dx. So d3y by dx3 is equal to what? So this one is simply your d2y by dx2. So write it here, d2y by dx2. Then we have minus sin x by 1 plus cos x. So what is it? The first thing, that is dy by dx, and you have a negative also, this negative. Now take everything on the left, you will get d3y by dx3 plus dy by dx into d2y by dx2, or the way you have to prove, just write exactly like y is equal to sine log x. We have to prove that x square d2y by dx2 plus x dy by dx plus y equals 0. So this type of question we have already done. To just recall, let us do it again. So we have y equals sine log x. So whatever is there in sine, it is not log sine, it is sine log x. So it will be simply cos. Dy by dx we need, d2y by dx2 also we need. So dy by dx is, this sine is cos. So it will be cos log x. Differentiation of log x is going to be 1 by x. Then d2y by dx2. So this again we are applying the quotient rule here. X square in the denominator, x remain here. Cos log x is minus sine log x, and differentiation of log x is 1 by x. Minus. Now cos log x will remain like that. Differentiation of x is going to be 1, because you have to differentiate x, and dy dx of x is 1. So now this the first term x gets cancelled. You have negative sine log x minus cos log x, minus sine log x minus cos log x, and divided by x squared. So this y is sine log x. Now you have a x square with d2y by dx2. So you can directly take x square on the left, or you can do like this, minus sine log x divided by x square minus cos log x by x square. d2y by dx2 is here. Now multiply all of it by x square. So I am multiplying this, I need this, I will get rid of. Minus sine log x. What is minus sine log x? It's y, so it will be negative y. And then cos log x. What is cos log x? So cos log x from here, if you take x on the left hand side, cos log x is going to be x into dy by dx. So this total is dy by dx here, and this x here. Now take it on the left. So x square d2y by dx2 plus x dy by dx minus y is equal to 0. This is the answer. And how are we going to write it? This is given here. So this is the whole steps you have to follow and write. Y is equal to 3 e to the power 2x plus 2 e to the power 3x. We have to prove that d2y by dx2 minus 5 dy by dx plus 6y equals 0. So this question you can do by yourself. It's quite easy. But let us complete it by solving. Y is equal to e raised 2x plus 2 e raised 3x. So dy by dx is 3. e to x is e raised 2x. Differentiation of 2x is 2. Then 2 e raised 3x. Differentiation of 3x is 3. So you get 6 e 2x plus 6 e raised 3x. This is your dy by dx. So now we have to arrange it such that we get dy by dx and dy with d2y by dx2. So for that we have to find out d2y by dx2. So 6 e raised 2x, 2x is again 2, plus 6 e raised 3x is e raised 3x, 3x is 3. So we have this d2y by dx2 as 12 e raised 2x plus 18 e raised 3x. Now as I said, we need 5 and 6. So we have, see, 30 e raised 2x. If you write 12 as 30 minus 18, so 12 e raised 2x can be written like that, and 18 e raised 3x can be written as like this, 30 e raised 3x minus 12 e raised 3x. So this 30 you can combine together, 30 e raised 2x plus e raised 3x. You can combine them. I mean, the 30 terms can combine. And what about this e raised 2x and e raised 3x? It can be written as negative. 18 e raised 2x, this will be plus 12 e raised 3x. So let me just make it as plus in a short while. Now I'm taking 5 outside from here. You will get 6 e raised 2x plus 6 is e raised 3x. I'm taking 6 from here. So 6 3 is 18, 3 e raised 2x, and this is plus, as I said. It will be 2 e raised 3x. Now this is nothing but what? We already done that. It is dy by dx. So 5 dy by dx minus 6. What is this? This is the original thing. Y minus 6y. So d2y by dx2 is this. You bring everything on the left hand side. d2y by dx2 minus 5 dy by dx plus 6y is equal to 0. This is your final answer. Y is equal to cot inverse x square. We have to prove that y2 x square plus 1 whole square plus 2x x square plus 1 y1 equals 2. So for reference, because this kind of question we have already done, I guess. So this is the reference for you. I may be doing it in a different way. Maybe sometimes it matches with the solution. Sometimes it doesn't. So y is equal to cot inverse x whole square. dy by dx is equal to, so twice come in front, cot inverse x. Then differentiation of cot inverse x is negative 1 by 1 plus x square. So cot inverse x differentiation is negative 1 by 1 plus x square. So what do you get? Minus 2 cot inverse x divided by 1 plus x square. This is your y1 you can call as dy by dx. Now y2, that is d2y by dx2, we are going to find out. So 1 plus x square whole square, 1 plus x square here, differentiation of minus 2 cot inverse x. So minus 2 will remain like that, and cot inverse x differentiation is negative 1 by 1 plus x square. So minus 2 will come here. Cot inverse x differentiation is minus 1 by 1 plus x square. Then you have minus here. Then we have same thing here, minus 2 cot inverse x divided by 1 plus x square, and differentiation of 1 plus x square is 2x. Okay. So this 1 plus x square gets cancelled, minus plus, so 2. This also minus will become plus. 2 into 2 is, you can write as 4x cot inverse x. So you can write it as 2x into 2 cot inverse x. Okay. 1 plus x square whole square in the denominator. So 1 plus x square whole square here. 1 plus x square whole square. You can write it as 1 plus x square into 1 plus x square. So y2 is this. So 2 by 1 plus x square whole square. What is it? So let us remove this and bring it to the left hand side. 1 plus x square whole square. 2 will remain like that. Don't worry about that. 2x, 2 cot inverse x. What is this? In the question it is saying, do we have anything like this? Yes, we have it. Minus 2 cot inverse x into 1 divided by 1 plus x square. So what we'll do, we'll multiply a numerator and denominator by 1 plus x square. So like this. So when you introduce this numerator denominator, one of the content we got as y1, but it is negative. So I am multiplying negative 1 numerator denominator, and this negative 2 cot inverse x divided by 1 plus x square is what? Is y1. So you have 2 plus y1. 2x is already there. 2x already, and the shape I made inside that, it was y1. There is one more thing. 1 plus x square we also introduce. So 1 plus x square is also there, and you have 1 plus x square whole square into y2, and bring everything on the left hand side. 1 plus x square into x whole square into y2 plus 2x y1, 1 plus x square, and this 2 you can keep it on the right. This will be on the right. Okay, this is your solution. So this question, I'll just give you a reference and we will do it entirely. Okay, the only thing which you need to know is the differentiation of cosec inverse x. So y is equal to cosec inverse x, dy by dx is equal to negative 1 divided by x square minus 1 in the root. This you need to remember. d2y by dx2 is the denominator, just square it. This will be x square, under root x square minus 1 will be x square minus 1 only. Then this x into under root x square minus 1 goes here. Differentiation of negative 1 is going to be 0. So let me just write 0. Constant differentiation is always 0. Then you have minus differentiating this x under root x square minus 1 will remain like that. So d by dx of x under root x square minus 1 we have to do. Let us do it now. So this x, I am using the product rule, x d by dx of x of under root x square minus 1 plus under root x square minus 1, d by dx of x is 1. So I am doing it using the product rule, x plus under root x square minus 1, d by dx of x is 1. So under root x square minus 1 can be written as x square minus 1 to the power half. Differentiation will be half x square minus 1 to the power half minus 1. This is half x square minus 1 to the power half minus 1 is negative half, and differentiation of x square minus 1 will be 2x, 2 gets cancelled, x will be in the numerator. This x square minus 1 to the power minus half will go in the denominator, it will have a root. So this under root x square minus 1 will become x by under root x square minus 1. So we already have under root x square minus 1. If you want to resolve, you can resolve it here. So let us resolve it here. Minus first term is already 0. Minus into minus 1 is plus. So only the numerator will be d by dx of this only. So just do it. So we have, this is x square by under root x square minus 1. X square by under root x square minus 1 you will get. And then in the denominator, so this x square into 1, that is x square only. And this under root x square minus 1, under root x square minus 1 will be x square minus 1. Oh, there is a slight thing, x, this is not x, this is x square. I'll just change it. Okay, so you have x square. So you have x square plus x square minus 1. You will get 2x square minus 1. And the denominator you have under root x square minus 1. So this can be written as 2x square minus 1 divided by x square is already there. X square minus 1 is also there. And under root x square minus 1 will come like this. Under root x square minus 1. d2y by dx2. Now you see this x square minus 1 into x can be taken on the left hand side. So first we'll take x square minus 1 on the left. This I am separating these two to x square minus 1 term and minus 1 terms with the denominator. So this has been separated, and as I said, we have d2y by dx2, x square minus 1 is in the denominator on the right hand side. Multiply everything, all of it by x square minus 1. So x square minus 1 will come here. Now just delete this. This is x square you can cancel, but no need to, because we will just keep the x, because x by under root x square minus 1 is ultimately what we need. So can we make this negative 1 by x under root x square minus 1? That is what we want. So this is 2 by under root x square minus 1. So under root x square minus 1, we have introducing x. So negative x and negative x in the numerator, denominator I am myself introducing, because one of the term is going to be dy by dx. Rest of the term will be as in the question. Alright. So this is dy by dx, this portion which I made. So this is minus x divided by minus 1 is minus x, so minus 2x, and that this whole content is going to be your dy by dx. Then your minus 1 by x square under root x square minus 1. So minus we already have. So we have this x square is there. So you can just write it as x into x. So 1 by x under root x square minus 1 with a negative. There is a negative sign in front. This is going to be dy by dx, and we have 1 by x also. So as I said, minus is also included. So there will be a plus sign in between, right? Now x square minus 1 here, d2y by dx2. So we have an x extra in the denominator of the second term of the right hand side. So what we'll do? We'll multiply everything by x. This x square, this goes. Now bringing everything on the left hand side. X square minus 1 d2y by dx2. And then we have this dy by dx. So it will be dy by dx on one side. And this 1 minus 2x square, when it goes on the left hand side, it will be 2x square minus 1. So you can have, so this minus 2x square plus 1. So we have this d2x square minus 1 dy by dx equals 0. This is what you have to prove. X is equal to cos t plus log tan t by 2. Y is sin t. We have to find out the value of d2y by dt2 and d2y by dx2 at t equals pi by 4. Now remember, there is a question already being done. There is a question following also where t will be equal to pi by 3. So please understand it very carefully, because the reference is already given, the answer. So let us start. For those who want to understand, x equals to cos t plus log tan t by 2. And dx by dt we are going to find out first. Dx by dt. So dx by dt, dy by dt, then dy by dx. This is how we proceed. So dx by dt is cos t is minus sin t. Log tan t by 2 is just 1 by that thing, that is tan t by 2. Then differentiation of tan t by 2, that will be sec square t by 2. And differentiation of t by 2 also will be done, that will be half. So this sec square t by 2 and tan t by 2 can be simplified. How it can be simplified? Because we have to make it more simpler, so that we can divide it by dy by dt for the later part. So tan t by 2 and sec square t by 2. Sec square is 1 by cos square, and tan is, since it is in the denominator, sine by cos, basically sine by cos. So it will be cos by sine. 1 by sine by cos is cos by sine. So 1 cos gets cancelled, you have 1 by sine and cos. The angle is t by 2. So 1 by sine cos. So we can write it like this, minus sine t. As I told you, this one. So there is 2 already here in the denominator. 2 sine cos, and 2 sine theta cos theta is sine 2 theta. You know already that. 2 sine theta cos theta is sine 2 theta. Sine 2 sine into 2 into t by 2. So this gets cancelled, sine t we have. So you can write it as 1 by sine t it is, remember. So let us take the LCM. Multiply these two, minus sine t into sine t is minus sine square t. Multiply these two, 1 into 1 is 1. Multiply the denominator, write it here. If you have any problem with finding out the LCM, then this is the best way. So 1 minus sine square t in the numerator, and in the denominator we have sine t. Now sine square plus cos square is equal to 1. So 1 minus sine square is what? It's cos square. So cos square t divided by sine t it will be. So this is your dx by dt. Now we are doing dy by dt. So what is y? Sine t. So d by dt of sine t. So sine t differentiation is simply cos t. But we have to find out d2y by dt2. This one, d2y by dt2. So let us differentiate one more time. d2y by dt2, t2 cos t is minus sine t here. And we have to find it at pi by 4. So t equals pi by 4, it will be minus sine pi by 4. So minus sine pi by 4 cos pi by 4, sine 45 degree cos 45 degree, both are 1 by root 2. So negative 1 by root 2. First thing we have found out. Next one is d2y by dx2. In order to find it, we need to have dy by dx. dy by dx is nothing but dy by dt divided by dx by dt. Alright. So dy by dt divided by dx by dt. dy by dt is what? This one is dy by dt. We have already found out it as cos t. dy by dt. And dx, this dy by dx, in order to find out this, dy by dx, dy by dt divided by dx by dt. So we have this cos t divided by cos by t, sin t goes up, so I am writing it in the numerator. One cos you can cancel, sin t by cos t is going to be tan t. So d2y by dx2 is equal to, see, this is when we differentiate it, we have to do or include the dt by dx also. That is, when you will do d2 by dx, d2y by dx2, tan t differentiation will be sec square t, and since it is with respect to x, you have to introduce dt by dx also. So sec square t multiplied by dt by dx is already computed, which is dt by dx is dx by dt reciprocal, right? So dt by dx is this one, cos square t by sin t, we want dt by dx, so it's going to be like this, sec square t multiplied by sin t divided by cos square t. Okay, so you can take sec square t in the denominator, it will be cos square t and cos square will become cos to the power 4. So we have sin t divided by cos to the power 4t. So this d2y by dx2. So at t equals pi by 4, we have to compute t equals pi by 4. So sin pi by 4 is what? Sin 45 degrees 1 by root 2. Cos raised 4t. So it will be 1 by root 2 to the power 4. 1 by root 2 and divided by 1 by root 2 to the power 4. So 1 by root 2 into 1 by root 2 into 1 by root 2, 1 by root 2. Oh, remember, it's sin pi by 4 divided by cos to the power 4 pi by 4. And cos pi by 4 is 1 by root 2. So 1 by root 2, 1 by root 2, 1 by root 2, 1 by root 2 is in the denominator. So whatever we get, 1 by root 2 into root 2 is 2, root 2 into root 2 is 2. So you get 1 by this 4. Okay. So I'm just changing it because sin pi by 4 by cos to the power 4 pi by 4 is nothing but 1 by root 2 divided by 1 by root 2 to the power 4. So what do you get? You get 2 root 2 out here. So this is d2y by dx2, 2 root 2, and d2y by dt2, that also computed, that is 1 by root 2. So as I said, these questions we have already done. Just now we have computed one question. So this question I leave it for you. I am also giving you certain hint here as a solution for your reference. If you are stuck somewhere, you can have a look here. Now x is equal to a cos t plus t sin t, y is equal to a sin t minus t cos t. Then find the value of d2y by dx2 at t equals pi by 4. So as I said, this question at t equals different values we have already done. So x is equal to a cos t plus t sin t. So dx by dt we are going to compute first of all. It's a cos t is minus sin t, and t sin t I'm doing it here. Let's do it somewhere else. So t sin t. So we'll apply the product rule. T cos sin t is cos t. Then we have sin t. D by dt of t is 1. T cos t plus sin t. So we have sin t plus t cos t. Now sin t gets cancelled. We have t cos t. So a into t cos t, it will dx by dt is going to be this one, a t cos t, a t cos t, dx by dt it is. Now next one is dy by dt we have to find out. So y is a sin t minus t cos t, a multiplied by sin t minus t cos t, dy by dt equals a sin t is cos t minus t cos t. This is t cos t is minus sin t plus cos t, t differentiation is 1. So you have minus t sin t plus cos t, but since it has a negative outside, so it will be t sin t minus cos t. T sin t will be in positive, please remember. So I'm just changing the sign in order to get the cancellation also and the t sin t in positive. So finally dy by dt, a cos t, this dy by dt in this, a cos t and a cos t, or you can call cos t and cos t can be cancelled, and we have t sin t remaining with a. So it will be positive. at sin t, dy by dt is at sin. So both of these dx by dt and dy by dt has been computed. Dx by dt is at cos t, dy by dt is at sin t. Alright, so dy by dx will be dy by dt divided by dx by dt. Let us divide them. So we have at gets cancelled, sin t by cos t is tan t. So dy by dx is, this is tan t. Now d2y by dxt we have to compute. This is tan t, d2y by dxt. So this is going to tan t will be, differentiation is sec square t, but we'll not stop it here because we are differentiating with respect to x, but we have t on the right hand side, so we have to do dt by dx also. Tan t is sec square t, but dt by dx also has to be included, and dx by dt we have already computed, it is at cos t. So this dt by dx will be the reciprocal of that, that is 1 by at cos t. So sec square t divided by 1 by at cos t. So we have this sec square t will be in the denominator, it will be cos square t. So 1 by at cos cube t it will be 1 by at, this sec square goes in the denominator, it will be at cos cube t. Now d2y by dx2, this expression we have found out, but we have to find out it at t equals pi by 4. T equals to pi by 4. So 1 by a and t is pi by 4 we have to use. Cos cube pi by 4 is what? Cos pi by 4 is 1 by root 2. Cube is 1 by root 2 into 1 by root 2 into 1 by root 2. That is root 2 becomes 2. So 1 by 2 root 2 it will be. So 1 by 2 root 2 we have 1 by a into t. T is already, a is a constant. T, as I already told you, is going to be pi by 4. And cos cube pi by 4 we have already computed is as 1 by 2 root 2. But this following computation will give you 8 root 2 by a pi. How? This is there. Let us compute it. So I am putting now the values of t here as I just suggested, and all these values, that is t equals pi by 4, t equals pi by 3, t equals pi by 6. These are the values which are given in order to compute these kind of questions. So I am putting it as 1 by a, and then t is pi by 4, then we have 1 by 2 root 2. So we have 8 root 2 divided by 8 a pi, and this is your value of t d2y by dx2 at t equals to pi by 4. Now this similar question like this says this t is equal to pi by 3, and as I said we have already done a question like this, a equals a cos t plus log tan t by 2. Just I am telling you that t equals pi by 3 is equal to nothing but your 60 degree, and how do we compute it? We just multiply the radian angle by 180 by pi. When we multiply this 180 by pi, we get 60 degree. Okay, so these all computation you have to do. You know how to do this. X is there, y is there, dx by dt, dy by dt, divide it. You will get dy by dx and then d2y by dx2. So when you divide this, you have to just, wherever t it is there, it has to be put in as 60 degree. Alright. Now this is also a similar kind of question. There are a lot of 2t involved. So 2 will come in front. That is the only hint here for you to be cautious in solving these kind of questions, because when you have this cos 2t, cos 3t, cos 6t, this number, if it varies, then you will get your question wrong. Okay, so let us do this. X equals a, and we have this cos 2t plus 2t sin t. This is x. X is equal to a. A is outside, so we won't consider it until we have solved it, because a is a constant anyways. So dx by dt. So a cos 2t is minus sin 2t, and differentiation of 2t will be 2 only, plus 2. Now t sin 2t, let us take it somewhere else and differentiate it, and let us bring it back. So t cos 2t, and we have differentiated this sin 2t as cos 2t, differentiation of 2t is 2. Now sin 2t will be there, differentiation of t will be 1. Now this is whole, we have just differentiated t sin 2t. 2 was already there outside, so let us multiply this whole what we got with 2 and write it here. So it will be 4t cos t plus 2 sin 2t. These two gets cancelled, you have a outside, then we have 4t cos 2t. So we have 4at cos 2t, this is your final 4at cos, or you can call it as a 4t sin 2t, because they are going to be eliminated in just a while. Dy by dt is a sin 2t minus 2t cos 2t differentiation. We have a sin 2t minus 2t cos t. Dy by dt, we have to find out a sin 2t will be cos 2t. Differentiation of 2t will be 2, and we have this 2t cos 2t. So we'll take t cos 2t somewhere else, and remember there is a negative 2 outside, so whatever comes up in differentiation of t cos 2t, we have to multiply it by negative 2, and then we have to write it here. Alright, so I'm just taking t cos 2t right now, and please remember to multiply it by negative 2 by yourself. T cos 2t, so t cos 2t differentiation I'm doing. So t cos 2t will be minus sin 2t, differentiation of 2t will be 2. So minus 2t sin 2t plus. So cos 2t differentiation of t will be 1. So what do we get? Cos 2t minus t sin 2t 2. Or you can call it as cos 2t minus 2t sin 2t. I'm multiplying it by negative 2 also. I told you to remember that. So multiply it by negative 2 and write it here. Why we are doing it? Because there is eventually, in the first part, when we differentiated dx by dt, this 2 sin 2t got cancelled. Here 2 cos 2t will get cancelled. That is how your dy by dx will become easier to compute or to solve. So as I said, 2 cos 2t will get cancelled. You get a 4t sin 2t, a 4t sin 2t. Alright, so dy by dx will be equal to, so just take dy by dt divided by dx by dt. So a 4t cos 2t, this you can just cancel this one. Sin 2t by cos 2t is tan 2t divided by dx. Next one is d2y by dx2, that is differentiation of this one. Tan 2t, you already know it is going to be sec square 2t, and differentiation of 2t is going to be 2. So sec square 2t, and this gives you 2 sec square 2t, but you are differentiating with respect to x, not with respect to t. So when you have a t on the right hand side, you have to include dt by dx also. We already know dx by dt, which is computed to be a 4t cos 2t. You just have to divide it, because you have to write it here as dt by dx. So when you divide this sec square and cos we have in the denominator, so eventually it will become, you can write in the numerator as x cube 2t, or in the denominator as the other way, that is wherever you want. If you are comfortable with sec angle or cos angle, better is to use this sec. We always appreciate things in the numerator. So we have sec cube 2t divided by 2at. This is d2y by dx. So this is your final one. The next question is x equals 3 cos t minus 2 cos cube t. Y is equal to 3 sin t minus 2 sin cube t. We have to find out d2y by dx2. So we have x as 3 cos t minus 2 cos cube t. Now in order to find out dy by dx, we have to first find dx by dt and then dy by dt. So let us find out dx by dt. 3 cos t is minus sin t, minus 2 cos cube t will be 3 cos square t, and then cos t will be minus sin t. So I am making this as plus and the sin t. So dx by dt this is. So you can just write it simply like this: minus 3 sin t, 3 to the 6 cos square t and sin t. So I'm taking minus 3 sin t common because it is going to be used later on. And inside this you have 1. Here you have 1 minus 2 cos square t. So this 1 minus cos square t and 2 sin square minus 2 sin square t minus 1 will be cos 2t. You'll just see. So this I'm just writing as cos 2t. Actually it is negative, but I'll just first do the y part. This is y. Y is 3 sin t minus 2 sin cube t. So dy by dt will be 3. Sin t will be cos t minus 2. Sin cube t will be 3 sin square t. Sin t will be cos t. Differentiation of sin t will be cos t. This will be 3 cos t minus 6 cos t sin square t. Now I am taking 3 cos t common from here. So what do you get? 1 minus 2 sin square t. So please remember, cos 2 theta is cos square theta minus sin square theta, right? So cos square theta minus sin square theta. Cos square theta can be written as sin square, because cos square theta plus sin square theta is 1. So you can always write cos square theta as 1 minus sin square theta. So 1 minus 2 sin square theta is this cos 2 theta, but 1 minus 2 cos square theta or 1 minus 2 cos square t is negative cos 2t. Please remember. So in this dx by dt we have minus 3 sin t and minus cos 2t, because 1 minus 2 cos square t is going to be negative cos 2t, and we know that this minus 3 sin t and minus cos 2t is going to be positive. So we have cos 2t, because cos square minus sin square is cos 2 theta. Same thing we are going to apply, and we just have to see one time we'll write cos square as 1 minus sin square, one time we'll write sin square as 1 minus cos square. That is how it goes. Alright, so we have these two things, dx by dt and dy by dt, and finally we'll find out dy by dx. This dy by dt I'm just taking this dx by dt and putting it in the denominator of what we found by dy by dt. So as I said, it is minus minus, it is going to be plus. So 3 cos t 1 minus 2 sin square t is dy by dt, and 3 sin t cos 2t is going to be in the denominator. So 3 cos t, and you know that 1 minus 2 sin square t is cos 2t only. We have 3 sin t here. This is also cos 2t. This gets cancelled. 3 gets cancelled. Cos by sin is cot. Cos by sin is cot. So dy by dx is cot t. Now we are going to differentiate it. So when we differentiate it, d2y by dx2, cot t is minus cos x square t. We already know that. But we just don't have to stop here. Minus cos square t, we have to include this dt by dx also. And dt by dx is just the reciprocal of dx by dt, which was already being computed. As you know that. Minus cos x square t, dx by dt is what? We already found out, this one. So I am going to take this in the denominator and try to find out how we can simplify these two. So minus cos x square t, here we have sin t, we have 3 sin t cos 2t. So I am writing it here in the denominator, 3 sin t cos 2t. Then this sin t goes up, already we have cos x square t. One more cosec goes up, means cosec square and cosec will be cosec cube t minus cosec cube t divided by cos 2t, and it is 3. So just include 3. And this is the answer. X is equal to a sin t minus b cos t. Y is a cos t plus b sin t. We have to prove that d2y by dx2 is this term, minus x square plus y square by y cube. Now there will be certain differentiation, but this is quite an easy differentiation, because when we do this a, x and y will definitely come again. I mean x and y, you'll just see x is equal to a sin t minus b cos t. dx by dt is what? It's a sin t is cos t minus b cos t is minus sin t. So I'm making it as plus. And this dx by dt or dy by dx, all this we are going to use in just a while. So y we already know, it's a cos t plus b sin t. So it will be minus a sin t plus b cos t. Now dy by dx is dy by dt divided by dx by dt. So just relieving you from the different step of writing, I'm just putting this in the denominator. So dy by dx we have found out. So dy by dx is this term. Now we have to go for d2y by dx2. And since this is p by q form, we are going to apply the quotient rule here. So d by dx or dy by dx is d2y by dx2. Alright. So this is going to be differentiated again. d by dx or dy by dx. So differentiation of this, when you differentiate this, there is a t on the right hand side and you are differentiating with respect to x. So you have to include this dt by dx also. And dx by dt we already know, it's a cos t plus b sin t. So in order to find out dt by dx, we can have the reciprocal of this and multiply it with the final answer what we got, or what we are getting in a while after d2y by dx, d2y by dx2. Okay. Please remember, whenever I am writing, it's d by dx, but we are differentiating with respect to t. Okay, so this is, I am writing in the short form, cos t as cot t, sin t as sin t. So this goes in the denominator. Now just put whatever is in the denominator like that, and now we have to differentiate minus a sin t plus b cos t. So minus a sin t will be cos t, and this will be negative, and I'm just, because I know that it is cos t will be minus sin t, so it will be minus b sin t. Now this is the first term being done in the numerator. Now we come to the second term, and since the denominator has to be differentiated now. So the numerator has to be kept like this as it is. The denominator has to be differentiated. So we're going to write minus a sin t plus b cos t, and differentiation of this. A minus a sin t, because cos t is minus sin t, and b sin t is cos t. Okay. Now you can multiply anytime, but what I'm suggesting is, if you just see the intricacy, these things are nothing but what we have already. If you take negative outside, it will be a cos t plus b sin t, both the terms. So a cos t plus b sin t whole square, negative outside. Similarly here also, a sin t minus b cos t you need. So this is, if you take the negative common from both of these, you'll get a sin t minus a negative will be positive. It will be like this, okay? Minus a sin t plus b cos t whole square. And since, as I said, you can take negative from both the terms, multiply it positive, because minus will be positive. Or you can just take this minus a sin t plus b cos t, and because it is square, now you can take a negative outside, the negative whole square will be positive only. So finally you will get a sin t minus b cos t, and a sin t b minus b cos t is nothing but x only. So you have, as I said, negative you can take outside. When you take it as a square, negative will be positive, and this, it will be a sin t minus b cos t, which we already have, x. So first term was y, it was minus y square. Second term is x, so it will be minus x square. Denominator we have already y, so you can write y square here. Now this is not all, we have something else here. As I said, dt by dx also needs to be included. This dx by dt is already there with us. dt by dx is 1 by that thing, and 1 by that thing, which is a cos t plus b sin t, is nothing but y only. This is y only, so it will be y cube in the denominator. So what do you get? d2y by dx2 is equal to negative, you can take outside, x square plus y square divided by y cube, y by cube, because y square was already there, and that is y one more we got from dt by dx. Okay, find a and b so that y equals a sin 3x plus b cos 3x satisfies the equation. So this dy by dx and d2y by dxt just has to be computed and has to be placed in this equation. And let us see what do we get. Y is a sin 3x plus b cos 3x. So dy by dx is nothing but a sin 3x is cos 3x, and 3x differentiation is 3 only. And since we have cos already, so I am taking minus outside. It will be b minus b sin 3x, so on sin 3x differentiation will be 3. So 3a cos 3x minus 3b sin 3x. Now d2y by dx2, 3a cos 3x is minus sin 3x, and differentiation of 3x is 3 again. Here minus 3b sin 3x is cos 3x, and 3x is 3. So what do we get? Minus 9a sin 3x minus 9b cos 3x. So this is d2y by dx2 we have. So just put it here. dy by dx is also computed, and d2y by dx2 is already being computed. Now put it here. Alright. So just assume that we are starting from here. This is d2y by dx2. I am adding 4 into dy by dx. Whatever is there, dy by dx, multiply it with 3 and then write it here. So 12a cos 3x, multiply again by 4. It will be 4 is 12b sin 3x, and plus 3y. Y is a sin 3x plus b cos 3x. So it will be thrice of this. So I am writing it after multiplication, and this is equal to 10 cos 3x. Now take the sin 3x term together and take the cos 3x term together. So sin 3x, when you take outside, it will be minus 9a, then we have minus 12b, and then 3a, minus 9a, and all the term with sin 3x I am taking together. Minus 9a plus 3 is minus 6a minus 12b. This is sin 3x. And coming to the cos 3x. So cos 3x, this is minus 9b. Here we have plus 12a, and then we have plus 3b. So 3b minus 9b is minus 6b. You have 12a here. Write it as 12a. And cos 3x is already there. Okay. Now this is equal to 10 into cos 3x. So when you equate it with 10 cos 3x, what does it mean? It means you have only the term 10 as coefficient of cos 3x, and there is no term of sin 3x. So minus 6a plus 12 minus 6a minus 12b. So it is negative, sir. Remember, there is a slight thing which I am going to change. Is equal to 10. Minus 6a minus 12a is equal to 10. Minus 12b equal to this minus 6b plus 12a equals to 10, and minus 6a plus 12 minus 6a minus 12b equals 0. What I am suggesting is cos 3x and sin 3x. You just have to take the coefficient and equate. Only cos 3x has some coefficient, otherwise no. So this way of solving will not be possible. I am just writing minus 6a equals minus is plus 12b. So minus 6a is 12b. That means we have 6 to the 12. So minus a is 2b, so a will be minus 2b. Second equation is what? Minus 6b, actual equation actually. Minus 6b plus 12a equals 10. Minus 6b, and since as I said, this has to be written here because I am writing a as minus 2b, I am replacing it by that. So 6b minus 24b is minus 30b is 10, b is equal to 10 by 30 in negative is going to be minus 1 by 3. But a is minus 2 into b, so minus 2, b is minus 1 by 3, so minus plus 2 by 3. So a is 2 by 3 and b is equal to negative 1 by 3. This is your answer. Now y is equal to a e to the power minus kt cos pt plus c. There are so many constants here. Please remember, t is not a constant because in the equation it is dy by dt, d2y by dt2. So t is x here. You can assume like that. So we can just call y equals a e to the power minus kx cos px plus c, and you have to find out dy by dx, d2y by dx2. Like that you can understand. Now at some point we are going to use p square plus a square as n square in order to find out this equation. Let us start here. This is the reference for you if you want to continue. I am solving it now. Y is equal to a e to the power minus kt cos pt plus c dy by dt is, so this t, as I said, you need to assume it like x because we are differentiating with respect to t. So a e to the power minus kt cos pt plus c e to the power minus kt, a we are going to use it just now. So I am applying the product rule. Cos pt plus c is minus sin pt plus c, then pt plus c will be differentiated. This pt plus c is going to be p only. Then we have cos pt plus c. Now we are going to differentiate e to the power minus kt. It is going to be e raised minus kt. Differentiation from minus kt will be minus k only. Okay. So there are certain things which you can place here. We already have a here. Minus a e to the power minus kt cos pt plus c is already with us in the second term. Alright. This you can write directly as y. I'm saying there is only k extra. So you can just write minus k. This whole is going to be y. So minus ky, the second term. What about the first term? Minus a, this, as I said, p, I'm bringing it in the front. So minus pa e to the power minus kt pt plus c. This is dy by dt. This is the way, or you can just d2y by dx2 here. And again the same thing is going to happen. There will be term which can be easily counted for y. I mean replaced for y. So d2y by dt2. This is, I am writing d2y by dx2 plus, but you need to understand I am not writing it. I'm just trying to explain that this is nothing but d2y by dt2 only. So minus k dy by dt. This was already there. Minus ky I differentiated. And minus pa e to the power minus kt pt plus c, I'm doing it separately. Minus ky differentiation already being done. The second term, minus k dy by dt. So this e to the power minus kt minus pa I'm going to include just now. This term was what? So this is sine. So I just left this sine, so I'm writing it again. So e to the power minus kt, sine content will be cos content, and pt plus c differentiation will be p only, plus sine pt plus c will be like that. E to the power minus kt will be e to the power minus kt, and then differentiation of minus kt is going to be minus k. So what do we get? E to the power minus kt cos pt plus c. P is already there, and remember minus pa I have not written, it will be multiplied just now. Minus pa is already there, so I'm writing the other terms here. Minus k to the power minus kt sine pt plus c, minus pa is already there, so need to multiply here. So multiply it here. I'm saying we are multiplying the first term and the second term with minus pa. It will be p minus p square. Then a was already there with multiplication, e to the minus kt cos pt plus c. Here also minus pa we have to multiply. Minus will be plus. We have pa k e to the power minus kt sine pt plus c. Right? Minus k dy by dt with this term. This is the term we got after differentiating minus pa e to the power minus kt sine pt plus c. Let us see. Minus p square y, because this whole term is as we just did few seconds ago. So this can be replaced as y. And this whole, please remember dy by dt was what? Dy by dt minus pa e to the power minus kt sine pt plus c, and we already have it. So pa e to the power minus kt and sine pt plus c. Only k is not there, otherwise everything is there, right? So we are going to write minus ky and k dy by dt. So if you multiply this y, the first term, that is if y equal to this, both sides with k, ky equals to ka e to the power minus kt cos pt plus c. So you can just replace it by k. Pa e to the power minus kt sine pt plus c. So this whole one is what? We already done this. This is minus ky minus dy by dt. So just for this, because dy by dt is already been computed, you can write it as minus ky minus dy by dt. So minus p square y was already there, and there is k multiplied. So I'm doing it as k square and k. So d2y by dx2, this whole is there, and as I said, this minus k dy by dt was already there. So this is also there. So it will be, there is already minus k dy by dt here. So minus k dy by dt twice is minus twice k dy by dt. So minus k dy by dt two times this whole, minus 2k dy by dt. We have here minus p square y minus k square y. Let's just write it as minus. If you take y common, it will be p square plus k square. But in the question it is already there, p square plus k square is equal to n square. Yes or no? So we can write it as n square. So minus 2k dy by dt minus, this is n square y. N square y, we have d2y by dx2. And this, all of the term on the left can be taken on the right, on term can be taken on the left. d2y by dx2 here, minus 2k dy by dt minus final term will be d2y by dx2 plus 2k dy by dt plus n square y equals 0 after replacing p square plus k square as n square. So I am writing the final term here. This term plus n square y equals 0. This is your answer. So this is the way you have to do it. Okay, this is all about this exercise. Thank you so much. Take care of yourself.